All right. Everybody that came in person, thank you for coming. It's pretty cool to see a little group of people focused on the same thing. Ultimately, peer-to-peer networks kind of replicate real life where, your community, people you know, people you exchange with, kind of create the basis for everything in your life, right? Uh, and that's one of the really interesting things about decentralized systems is that on one hand you have like technical parameters, but on the other hand you have a social system. And kind of like any social system, you have various levels of like trust. Sometimes you could call that belief. And in the extreme, I would even say it's healthy to have an element of faith, right, in each other, people in your networks. Now that is both something that uh, can offer a lot of benefits, right? It can allow you entry into a peer-to-peer system, but it's also something that is an attack vector, right? If you have people that kind of exploit your trust or your belief or your emotions, that doesn't always end well. I had a presentation put together to kind of cover the basis of Ergo itself. And then I was thinking last night, everybody here anyway, and many people that are probably tuning in already know these things, right? So what is the point of just repeating, um, I don't know, what's publicly available, and anybody with some time, energy, or desire can easily read. Now I know that's somewhat of a skill that's being lost, is the ability to read, but it's there, right? I do think it's fascinating, kind of the events of yesterday, right? So let's just speak to the moment. Yesterday, I was out having some beer and some food with some of the people that showed up, completely oblivious to, the workings of kind of the broader crypto ecosystem. And you come back, and they're like, "Oh, there's been a spiral effect of deleveraging and billions have been removed from the market and what's happening and all these people I don't know, hopefully manage their risk, right? A good starting point is understanding like risk management and leverage. Leverage is a powerful tool when it's needed, right? But it's also risky. It's not without its trade-offs. And I think that sometimes you have the talking heads in the crypto industry that do not like to talk about risk. And I think that's a fundamental failure of the cryptocurrency ecosystem broadly, because ultimately in our world, money is a control system, right? We live, let's say, within the United States. You have a group of people on a hill somewhere, they say, right? And they go into a room and they discuss in private. Okay, publicly they'll say we have two parameters. We want to have employment at a certain level. We want to have inflation at a certain level. And those two don't necessarily correlate in terms of how they move anyway, right? But they go into a room in secret and everybody around the world gathers and watches. Say, what are they going to do with our money, right? What is going to be the cost of money? And we sit around and speculate, and sometimes people have fun on Polymarket or whatever. And eventually, smoke comes out of the chimney, and we say, "Okay, this is our new updated policy, right? We've forked the network, so to speak, and this is going to be the cost of money." And we go through this ritual, regularly. People around the world tune in and watch and position and try to um, kind of front run whatever that trusted setup is going to be. And then on a higher level, we have this idea of, um, let's call it the type of cross-chain tariff, right? Where arbitrarily you have new costs added to the system. That's, I guess, what was a part of the madness yesterday, more or less. Let's see. Where suddenly, you have these two economies that interact, and we're going to add 100% tariff, right? And there's no real consensus mechanism to understand what is coming, right? It's a trusted system where the individual has very little power. They have very little power in terms of understanding what the assumption is today and what the assumptions are going to be tomorrow. And that's not the type of environment that produces, I don't know, the right mindset for risk itself, right? And that's one of the most interesting things about this idea that started with Bitcoin is saying, okay, can we have a system where the parameters are set, right? Where monetary policy is more or less set, and then build economy on top of set expectations. And based on how the network is set up, within a certain set of assumptions, you can assume honesty. That's powerful. If you look at kind of the traditional system um, that we're all born into, it's something we just naturally inherit. It changes depending on where you're from, right? But it's kind of more or less the same system where you have a high concentration of power, and then, of course, one of the most profitable things is to be close to power, right? Close to where money is being distributed from. And generally, the further away you get from that initial distribution point of money, the more inflation and expansion of money supply tends to hit, right? I would say a lot of the crypto has industry has really gotten away from first principles. And in my opinion, that's based on toxic social systems, right? Because that social system is inherent to these type of networks, right? Where you constantly have people that are saying, trust me, believe in me, have faith in me. Um, and I think that is not the ideal environment to create the systems that we want to build, right? It's a part of why, at least with Ergo, I've always tried to push for build in public. That we should ideally have these primitives in place that are the equivalent of public goods. They're open, they're auditable, and hopefully through time and with testing, they also become extended, right? They become extendable. You could look at something within the Ergo network like Sigma USD, right? You have first, it's based on research, right? It's not something that is just willy-nilly thrown together, which we do see a lot of that in the space, right? So as an experiment, it has a solid foundation, right? Then you have kind of open code, open parameters around that experiment. That even if the experiment itself experiences difficulty, you have the ability to extend it, adjust it. It's open, right? It's open to new ideas, it's open to new iteration. And ultimately, through time, I think we can build solid public goods with that framework. And my hope would be that creates its own flywheel effect, right? Everybody in crypto these days will talk about, oh, the flywheel, right? In terms of, you know, financial games, right? The ideal, in my opinion, is to create flywheels with software to where you have these public goods that can then be reused, right? And the more diverse these building blocks come, you can suddenly cater to a larger class of functions and applications and build something that has a solid foundation. Sometimes we get away from this idea of open code. And I think that type of transparency should be a solid base for a healthy social system because it's based in trust, right? Not faith. We are a proof of work network, and proof of work, one of the interesting things is a coordination mechanism, is it's leaderless. It's apolitical, right? And that's something that people often struggle with, like grasping in terms of the social system. They'll say, "Hey, Arminio, you need to, go dance over here, go do over there. You're, supposed to be a leader." And it's like, well, I have a certain set of skills, right? But meeting everybody that attended, and I'm sure everybody watching, you have a different set of skills. No different than in the off-chain peer-to-peer economy, you bring different skill sets, different abilities, different specialties that you've developed through time in your life, and you create value using those. I don't think there should be that much difference. Like I'm not universally uh, intelligent enough to be the leader of everything, right? I have my areas where I would say I've, learned and grown and developed a certain skill set, but in other areas, you do not want me in charge, right? I'm not the guy. And people struggle with that because in social systems, a lot of the competition is to be the guy, right? If certainly if I have people's trust and belief and faith and they follow me, um, I guess that's an attack vector that we see all the time in crypto. And it's funny how, the sheep are taught their entire life to fear the wolf, and then in the end, the shepherd eats them, right? So having that um, basis of how do we create trustlessness, not just in software, but also in the social system itself, that takes responsibility. It takes a collective responsibility, right? We're going to build things the right way. And at least in extended UTXO, there is a trilemma, let's call it. You have the contract itself, you have the off-chain logic, you have the front end, right? In the ideal scenario, all three of those can be replicated locally. That's what I would say makes for a decentralized application. That's pretty clear parameters, right? So as an ecosystem, I think it's healthy to really push for that. That's something that I've always tried to promote. And it's hard to build open code, right? Because you are, in essence, being naked in public. It is sometimes a process to get there, right? But I think that is ultimately a solid goal in terms of building public goods. So we hear about this trilemma in blockchain all the time. You usually have it's a selling point, for lack of a better term. It's a selling point. But I do think that within the Ergo ecosystem, anyway, I would like to promote the idea of our own little trilemma, which are those three aspects of an application. And ideally, if you have those three aspects that are open, and you have tooling that becomes kind of a common knowledge base for developers to use and build off of, you have things in place to start creating the right flywheel. That's kind of hard to bootstrap from nothing, but I think we've done a pretty good job as a whole of creating that mindset and mind share. And there have been a lot of developers, some of which are here, some of which choose to remain faceless, which I totally respect, that have contributed to that type of mindset. And so, everybody that's contributed to that ideal public goods, I kind of have to tip my hat to you. That's ultimately powerful when it comes to not just the network itself, but also the social system um, of the network. Now, from first principles, crypto should be about, the distribution of power. Proof of work kind of represents that in terms of the distribution mechanism of money itself, right? It's something that you can certainly compete for and build into, but having clear assumptions in terms of distribution of power is needed. And sometimes that is buried behind really good marketing. Sometimes that's buried behind social systems. Sometimes it's buried behind this trust me, bro mentality that permeates the crypto industry. And I think that's toxic. And I don't really care if people uh, don't like that, right? Because if you can't call a spade a spade, your social system's not going to work, right? That's just honest. I know there's a lot of financial games and cultural movements and things like that. I've said from day one, for me personally, I would rather go to a casino. I know the drinks are free, right? That's a solid assumption that I can bank on every time. And, whatever my parameters of risk are with the games that I play, at least I know that assumption's going to hold. Um, Now, security is another powerful mechanism of, uh, both the network parameters and kind of this social layer, because we do need to address both, right? Sometimes we see them as separate and they're extensions of each other, in terms of what people accept. Um, Security is, at least in our industry, is something that's formed through time, right? You usually have research as, the bedrock of computer science. Then on top of research, you have implementations, right? Where people will try to take research and use engineering skills to convert that into something that's tangible. And then you have the test of time, which kind of is the ultimate teacher in life. Um, so having things that are built on a solid foundation and are introduced and kind of go through this test of hardening through time ultimately should be a goal. That doesn't mean you can't innovate, right? It doesn't mean you can't extend. It doesn't mean you can't provide research. Certainly in Ergo, we have led in various areas of implementing things that kind of came from the academic sphere. But I think there's an element of wisdom in being conservative, right? And sometimes uh, that is not the focus of the crypto space, right? Innovation is wonderful, but I would also say that sometimes iteration is innovation, right? Where you take something, you extend it. It holds, you extend it. It holds, you extend it, rather than, trying to reinvent the wheel for the 700th time. And, it's good for marketing. It's not necessarily good for security, right? Because you have a weird curve distribution where through time, usually you have the research side, right? And like the engineering complexity, let's say is much higher. And then through time, as it becomes more of a standard, it becomes easier to adopt. There's better tools. Like that whole process of evolution is not something that you can cheat very effectively. It's something that is much slower than the hype cycles that people are taught, right? So I want everyone to remember when it comes to security that time is ultimately the test. We can look at kind of the first principle of privacy, which is probably fundamentally one of the most important things we need to explore, right? Um, there is some potential future where the children, uh, people in this room have could grow up into a world where every economic transaction they touch is audited, stored, and you could watch every penny that someone has touched throughout the course of their life. That type of control system is getting to the point where it's technically possible. And that should frighten the hell out of everybody, right? That type of system, I do believe there are some powers in this world. That's where they would like to take humanity, right? Because it certainly offers them, um, well, greater power and control. And so I think having the ability to remain private, anonymous, have your personal space, um, is going to be one of the most fundamentally important things that we need to work to protect as an industry, right? And that doesn't just mean we're going to add zero knowledge proofs to everything and have more control systems in place. I think that's a bit of a perversion from privacy itself, right? That's a trade-off that many people see as quite sexy, right? Where we're going to have ZK compliance, and if you just get more and more and more and more ZK compliance, you have a stronger control system. So I think we need to really look at this idea of privacy, make that an absolute, chase that on multiple layers of networks rather than have it be toy. Because, I would say in some cases, yes, it does offer like visibility assistance in terms of people not seeing your transactions or what's happening. But um, in terms of the broader assumption, it's toy privacy, it's not real. And I think we need to be very clear in terms of what our set of assumptions are long term with privacy and what the goals are with privacy. Because there are a lot of projects, there's a lot of research um, beyond Ergo itself that is valuable in terms of preserving privacy, preserving anonymity. I think that ultimately should be one of the most important tenets of creating censorship resistant systems and censorship resistant money. Um, the other area has to do with inclusion, right? We are seeing a mix in the space where it comes to regulated assets, non-regulated assets, bearer assets, non-bearer assets. And that needs to be something that there's a lot of clarity with, because not everything in crypto is the same. I know that in the social layer, everything is a ticker with some letters in it, right? But the underlying assumptions that you need to make in terms of, custodial, non-custodial, is this a bearer asset? Is this not a bearer asset? Is probably going to get even more complex when we start seeing regulated assets appearing, right? We've kind of seen some of this freeze and seize with stable coins, but the crypto industry is changing, right? Even yesterday or 2 days ago, there's an announcement that, these 10 major banks are going to collaborate and create some, stablecoin instruments. Oddly enough, they tend to be the same banks that own the corporation that's on the hill, but that's a side, uh, that's a side journey that, not probably not the rabbit hole for right now. But that type of assumption of inclusion is going to get really important. Um, I do know that Alex Kushti, as many call him, has been working on a whitelist mechanism, which I think is probably the better way to deal with like uncertainty in terms of power. Where, rather than you join and you might get blacklisted at any time for any reason, you make a voluntary agreement. And hopefully there's clear assumptions in that agreement in terms of the risks that you're inheriting in doing that, right? This last is probably this element of resilience, right? And ultimately, I think that's why open source code is so important, because good ideas are hard to kill, right? I do hope not just within Ergo, but within various aspects of the cryptocurrency space and some of the privacy space that's been around, we're able to develop tools that ultimately develop into truly resilient systems. I've operated under the belief that over the long arc of time, the only thing of value in cryptocurrency really is state resistance. Everything else will probably, in my opinion, distill down to the common denominator underneath, which is centralization, right? Because if you're not shooting for state resistance, ultimately the most efficient thing is going to prevail through time, and the most efficient thing will be centralized. Now, maybe it'll be pseudo-centralized. We can have a debate whether Amazon Web Services is distributed, decentralized, because you have data centers all over the place that optimize, um, speed. But I would say that in terms of power distribution, we have to be honest and say, okay, it is distributed, but the actual concentration of power there is pretty apparent. So over time, if we build on first principles, I do believe that the crypto space is capable of developing open source tools for coordinating capital and creating systems where within a certain set of assumptions, we can assume honesty, right? And luckily, at least with Ergo, we have this proof of work mechanism that has a pretty well time tested mechanism of, what are your assumptions of honesty? What are your attack vectors? In terms of the contractual layer that we've come up with, it is relatively conservative. So I think those are solid building blocks towards a larger goal. Sometimes within the social layer of crypto, you sign on to Twix, Twitter, X, whatever you want to call it, and you listen to the, uh, I don't know, commentary, the talking heads. It does kind of leave you wondering, what the hell are we doing, right? Why are we here? And I think that ultimately should be the most important aspect, is we need to have clear intent and clear purpose. Because if you don't have clear intent and clear purpose, you're not going to be grounded in what you do, right? And crypto as a whole, I would say, needs to be more grounded, right? I do hope that over time, we create a tool set that's diverse enough, and again, in extended UTXO, that's going to be contractual, it's going to be off-chain, it's going to be front-end wise. We create enough tools around those three problem areas, the trilemma, let's say, that we can serve a diverse set of needs. And I think sometimes uh, marketing and kind of just social spam buries that intent, right? So my hope in going through all of the presentations that we've set up, all of the speakers, everybody here is doing really unique things that are targeted, that improve like the assumptions, that offer new tools, and understanding that as a piece that can be replicated within a whole, uh, over time, I believe will lead to a broader tool set that's powerful. And I think we've done a pretty good job as an ecosystem, developing open public goods, sets of tools that um, have led to some interesting things. We just went through a major upgrade with Sigma 6 new node version, right? And that will open the door to a lot of new capacity. And I hope that as we kind of build to enhance new system capacities, we stay focused in on mission, because that type of purpose, I think, is important. It's not just important for like solid programming beyond the network. It's important for the social system. And the social system in crypto is very toxic. It's just honest. I sometimes have said, my favorite thing is seeing all of these tools that enhance individual like power, takes responsibility. My least favorite thing in crypto is people that look for a savior, right? Because that's not really how peer-to-peer networks work. That's the client-server relationship, my friends. So if we get back to this idea of saying, okay, how can we distribute power across peers and empower peers to have tooling, to have access, to have software that ultimately can serve them and their needs, that's the ideal for cryptocurrency. I would say everything else is just digital money. And I think we need to kind of lean into that because, you know, uh, the possibilities if, privacy does not work as an industry, if resilience doesn't work uh, as an industry, the trade-offs are huge in terms of the world long term, that could be spun up around us. And, sometimes I wonder what kind of world my children will live in, right? Like what will I can see myself. I was born into this strange system. You got the people on the hill, you've got, this distribution of power that I can't really touch or interact with much. But what about the future? How much stronger could that get theoretically? And that should scare the shit out of everybody, in all honesty. So for me, I think that kind of sums up the purpose, the intent of why I'm here, right? It's the only thing that matters. So I do hope that as an industry, it's something that, we can mature around, look at all of the trade-offs of control in different areas and build wisely. So I'm gonna kick it off to MG Pi and Luca. I need to set up their mics, set up their presentation, uh, get them ready to go. But thank you everybody for tuning in and enjoy.
Hey guys, that was a great speech from Joe, and thank you to Joe and the Sigmanauts for sponsoring and hosting this event. It's wonderful to finally see some faces. So today we're going to be talking about palm staking on the UTXO model. So over the last year or so, I worked on implementing a native token staking platform on Cardano. And as you know, Cardano and Ergo are very similar in terms of how their contracts work, and they all share the UTXO model. So I'll try to keep this as easy to understand as possible, so everyone can understand. So we have some existing implementations of staking already. So if you guys don't know, over the last cycle, DeFi summer, we had Sushi Swap and Pancake Swap. And for really anyone new here, Pancake Swap was like how Solana is today. Like they had all the memes and they were going crazy with all the meme coins, all the launches, and staking with those meme coins. And before Pancake Swap, we had a Sushi Swap, which really was a Uniswap clone, but they actually did some research and they were the first ones to implement this the modern native token staking or ERC20 staking. So Sushi Swap had this staking, which really is to incentivize people, right? Because staking makes people hold their tokens, right? So it kind of stabilizes price movements. And yeah, SushiSwap pioneered this, and then we got PancakeSwap, which basically copied it and made some improvements and really brought it to the mass users, right? Tons of people were just making meme coins and having staking with it. So, you don't sell those meme coins and kind of like a inflation and a Ponzi scheme and so on. All right, let's try to get to the next slide. So let's have a refresher. So what is the account model and what is the UTXO model, right? So the account model is all right, let's start with UTXO. The slide is here. So what are UTXOs? UTXOs were pioneered by Bitcoin, right? That's what how they started their entire mo system. So UTXOs stand for unspent transaction outputs. And the out it's basically the output of the previous transaction you did. So when you submit a transaction, you have a bunch of metadata, right? You have what went into the transaction and what came out of the transaction, and the outputs of this transaction is are referred to as UTXOs. And the transaction model really is an exact digital analogy to cash. So let's say I have a $10 bill and I want to pay for $6 coffee. It's probably $8 now, no inflation. And if I want to pay for $6 of coffee with my $10 bill, I can't just rip the bill in half, right? I have to spend the entire $10 bill. So what do? I give the cashier my entire bill, and that's it. They have the bill. They're not going to rip it in half or anything, right? It's just gone. But they're going to give me back $4, right? And this $4 is completely new, right? It's not the original bill, it's just completely new. The $10 I had, it's gone. So this is how you can think of the UTXO model. When you have an input, it always must be spent. It's always unique. You cannot spend an input more than once. Unlike cash, I guess like the cashier could spend it in other places, but in the UTXO model, it can be only spent once. And my another analogy that I like is with the old-fashioned piggy banks, right? So you would have savings in a piggy bank, and if you ever wanted to spend it, you would have to smash it open, right? It's like a one-time thing. So you can also think it of that, right? I have $10 in my piggy bank. The piggy bank is the UTXO, and that's like the input, right? And then if I want to actually spend it, I would smash the piggy bank open and it's gone, right? Just one time. So that's really a brief overview of the UTXO model. And Cardano and Ergo both make use of this. So what's the account model? Account model is really the newer model, and it was pioneered by Ethereum. And account model really is analogous to your bank account, where you just have a list of transactions saying that maybe $10 was deposited and you're spending $1, and you have a list of transaction history, right? So addresses are seen as accounts and you just have a direct tally of balance. And the thing with this, and I think of it as a problem, is that you need global state, right? So you need to know the history of everything from the start, right? When the account got funded to how much you have now, to know how much you have at this moment, right? You have to do, some calculations, right? Some balance add, balance deductions, and so on. So, but this is overall how the account model works, and it is also quite popular, right? All the Ethereum forks use that, and Solana uses that, and all the newer blockchains also use that. Um, for those of you following Cardano, they have a new blockchain called Midnight that they're probably going to launch, next quarter or so. And Midnight uses a hybrid of account model and UTXO, so it's quite popular. So let's talk about the advantage of account model in the context of this staking. So staking is more analogous to a client-server interaction. So what that means is that a server is really just a computer that never turns off, right? It's always running in the background. And client is really the people who hit that server, right? You need to talk to that server to do something. So, for example, if you're logging into your email account, right, you're accessing a server which, holds all your emails and all, right? And you're the client, you're trying to log in from your laptop, right? So that's a client server interaction. So staking is similar to this interaction where the stakers are the clients, right? And they deposit their tokens to a contract. And this contract, you can think of it as like a server in the sense that the contract has to manage all the global state, right? It has to track the balance so it knows how much rewards that you get, right? Because rewards are a function of how much tokens you deposit and how long you have deposited them for. So Solidity is the smart contract, a very popular smart contract language that runs on this account model. So Solidity is perfect, right? It has a single authoritative contract storage, right? So you have something called a map, and a map is a very basic data structure that you have a key. So a key is like the user, like your user, your wallet address, right? So and if you access the data within that wallet address, you have a bunch of data, right? Like how much they have deposited in the contract, and how long they had the tokens on, and all sorts of useful information. Perfect for this. And then this doesn't translate well to something in the UTXO model. So for UTXO contracts, you have a single UTXO, right? And each UTXO you can think of it as its own entity. So in UTXO has its each UTXO can have its own contract. So a contract's state really is with respect to the UTXO it's inside of. So a UTXO has this bottleneck, right? You can't just store infinite data in it, right? The UTXO, you have a size limit, and you also have a broader transaction size limit because you can argue that, hey, why don't you have like a bunch of UTXOs this single UTXOs interact with, right? So you can have like a bunch of data, right? So if a UTXO data size limit's like 4 kilobytes, you can be like, okay, why don't we just do like 1,000 UTXOs, right? Why not? Why not make it like 4 gigabytes or something, right? No, that's not possible because you have your bottleneck by transaction size limits. You can only deal with specific amount of UTXOs per transaction. And then on top of that, you also got the block size limit, right? So you can only have a certain amount of transactions per block. So a lot of bottlenecks here. So how can we move on with this, right? Like it almost seems impossible to bring something that needs such a large global state because remember, this might translate to like 10 users, 100 users. But how are we going to scale to like 10,000 users, right? Because all each user has are going to have some size of data, right? That's not going to scale. So how do we do this? So, I had to rethink staking on the UTXO model. So, data stored for the global variables, so for like all sorts of staking calculations, they need to be bound to a constant size limit. You can't have it scale with the amount of users, right? So you can't be like, okay, one user is like 1 GB of data, right? 10,000 users is 10,000 gigabytes. Like we can't scale like that. It has to be one user is like 1 GB of data. A million users is still 1 GB of data, right? How can we make that happen? It has to be constant. So a clear solution which several projects on Cardano and Ergo follow. So I think what was it? Ergo something or the people behind Crux Finance. I'm forgetting their name. I think they're shut down now, but they pioneered a staking model, and then a bunch of Cardano projects have their own staking. So what do they do? So they have some sort of position or UTXO or NFT that you can think of, which indicates a share of how much they have staked, right? So let's say you stake a certain amount of tokens, you'll get back like a unique token saying that, hey, this person staked like 100 tokens on the platform at this time, right? So if you ever want to claim that stake back, make an update, you have to deposit that unique token you got back into the contract, right? And this is a pretty straightforward and well-known solution to this problem. However, this was not ideal for Zengate's purpose because of legal conflicts. The problem is that you can have derivative markets of something like a position token because I can take my position token and I can be like, okay, I don't want to be in this anymore, but I don't want to. You don't want to lose like that accumulation of rewards, right? Like maybe, like the longer you stake, the faster you earn rewards or something, right? It keeps compounding. So maybe I sell it to someone else, or just give it to someone else, right? Or what if so you create these derivative markets, and it's a conflict from a legal standpoint. I don't know why, but it is what it is. It's a very gray area in general, unfortunately. So so I thought of this data structure called a Merkle tree, and this was absolutely perfect. So on Ergo, you have the AVL tree, and it's quite similar, so it can just translate to Ergo. Also, what's actually really interesting is that the Merkle tree data structure is something that was just implemented at a contract level on Cardano. However, on ErgoScript, you have a AVL tree as like a native data structure within the language. So what that means is that basically you can trust the data structure on Ergo more because like the core team, so basically Kushti made the implementation like in the compiler itself, right? So it's not like a third party code that you're trusting to be correct, which is which is the case on Cardano. So let's see what is a Merkle tree, because I honestly barely knew about it until I did this. All right, so a Merkle tree is a tree-based data structure, and a tree-based data structure you can really think of it having like a root at the top, and it has branches pointing to more roots, right? So you can kind of see that data structure in the diagram behind me. And the boxes, right? They're called nodes. So you have like one like root node, like it's the main node on top. Then you have those lines are called branches, and then you have like another node that's like called branches. That those are called like they're like intermediary nodes, and all the way at the bottom you can see a bunch of nodes, right? Like the final nodes. Those are called the leaves. Or that's just a very well-known data structure in computer science. So a Merkle tree is a variant of this data structure, and it's made by hashing hashes of data. So I know that's confusing, so let's break that down. So behind me, you can see that you have a block of data, right? Like a block of files. So A dot text, B dot text, C dot text, D dot text, and you hash this block of data. And hashing really means is that you take data of any size and you convert it into a fixed sized string of a certain data size, right? So in this or in well in most cases it's always 32 bytes of data. So it's like a string of 64 characters. And the cool part about this, which is really important in security context, is that it's irreversible. So if you have this fixed size string, you can't get the data back. It's impossible. But that's beyond the scope of this presentation. So again, you have a data and you transform it into a fixed size unique string. So you can see a dot text has a hash h1 z2, b dot text has its own hash, and so on. So how does this translate to a Merkle tree? So look at the tree behind me. All the way at the bottom, the leaf nodes, you can see that we brought those hashes over, right? The h1 z2 y 77A and so on, right? So those are the hashes brought to the node, and they're at the bottom. So now you look at the left side, the bottom left side of the tree. So H1, so we take the H1 Z2 Y 7FA. I can't read it from here. And so those are the hashes for a dot text dot b dot text, right? So we take those hashes and we concatenate them, we put them together, and we take the hash of that. So the hash of that you can see is right above those two, right? So it's U67R right on the left side. And again, we do this exact thing on the right side. So for C dot text and D dot text, and we get a hash. Now those like hashes in the middle, again, we take them, we concatenate them, and we get the hash. And that final hash is called the root hash. So why this is really cool is because you can find differences between two states, so meaning like two different trees. So if you made any modifications, you can find the difference between them like really fast because think of it logically, right? If you have two pieces of data, what do you have to do? You have to iterate through them, right? Like one like bit at a time, like the smallest like unit of difference, right? You have to iterate through them. So, if there's like a million pieces of like units of data, you have to make at least like at most a million iterations, right? It doesn't scale. So with this, it's a lot faster, right? It's like the log of a million, maybe that's like what, like 1,000 or 10,000, I don't know, but it's a lot significantly faster, right? So let me explain this further. So you can see that we had the text files, right? And we changed the contents of c.text. And what does that do? We got a new hash. So you can see 4W12, right? So on the right side of the Merkle tree, you can see that all the way at the bottom, that changed, right? It's in yellow. And now since that changed, the hash above it, which is remember made by concatenating the hash of c.text and d.text, that also changed, right? And since that changed, the root hash also changed. So you can see here that when you traverse the tree, you first check the left side and you're like, oh, the left side's exactly the same. So you know that a.text and b.text is completely unchanged. But then you go to the right side and you can see that okay, d dot text isn't changed, right? All the way at the bottom right, it's still the same. So then you know really quickly that c dot text is changed. Like so it's a really clever data structure and it actually powers so much of the modern infrastructure. You just don't know it. But that's a quick introduction to a Merkle tree. So yeah, you can see here like the comparisons made, right? So on the left side was the original tree, and the right side is the tree with the C dot text changed. So you can see we just make three comparisons, right? So this scales really well. All right, so now what we actually use for the staking is something called the Merkle Patricia trie. And what this is basically an optimized version of the Merkle tree. So a tree really is a is it just you can think of it as like a key value map, right? Indexed by like the keys nibble. So it's just like a bunch of characters, like ASCII characters, and that's what a trie is. And Patricia is just an optimization of the path, right? So it's a very optimized structure. So you make even less. So in the previous slide, we made like three traversals, right? So this makes it even smaller, like maybe like one or two. And then Merkle, is from what we discussed before. And then the proof is the path of nodes that you traversed, right? So in the previous slide, we traversed through like three nodes. So that's like the proof. You can think of it as that. And then proving, right? What is the action of proving? So you have the inputs of the known root hash, right? So the hash all the way at the top, you have that. And then you provide the proof. So you provide that path. And then you provide the key and the claimed value, right? So you walk through that from the root node to all the to until you get to the key, right? You walk through the tree, and then once you reach to the value, you stop, and then you compute the root hashes from that traversal, right? You can do that same hashing from the scratch, and then you compare it. Hey, is the thing I computed, does it match what I already know? And if yes, then you know that everything's correct, like no one's messing with anything, right? And yeah, so membership is proven when the computed root equals the known root, and the known root is what you passed in. So let's talk about how this integrates into staking. So client balances, right, are stored in this trie-based data structure. And on chain, so in the contracts itself, only the root hash is stored. And remember, the root hash is a fixed size string of 32 bytes, right? Because it's a hash. And that answers the problem in the, we saw a couple slides back where we want like one user to be like, say, 1 GB of data, and we want a million users to still be that 1 GB of data, right? So it's constant. So in this case, it's always a constant 32 bytes, right? Which is incredibly tiny. So it's always this number, even if we have a million clients, which is really cool. And thanks to that, the Merkle tree diagram I explained, right? It's hashes of hashes of hashes and so on. So anytime any insertions or updates done, the contract does verification, right? So as I explained in the previous slide, you have a proof and you have the known root hash. So you provide the proof and the known root hash. And what does the contract do? The contract only does computing, right? It only does verification. It all the doesn't need to do all the data storage or anything, right? You provide it the exact data that it needs, the least amount of data it needs to actually prove what you're doing is correct and you're not providing false information. So, and remember, after all of this is done, so if there's any like mutations done to the state, so meaning like if you added more stake or you did a claim or you did a withdrawal, that's a mutation, right? Um, the only thing that changes is the root hash, right? So it's always that constant size length. And when these updates and claims happen, like you're providing the proof, right? So you actually, so I guess the downside of this is that you have the overhead of you have to store this data somewhere. It's not magic, right? So you have to store the data in your own server, right? It's called the off chain. So you have to store the data. You're responsible for storing the data in Solidity. you can just throw it on the blockchain and you just make sure like the EVM nodes, right? The Ethereum nodes, the heavy 2 or 3 terabytes, 6 terabytes nodes, right? That stores all of that, right? So you just worry about that. But on the Ergo sense, you are storing the data. Yeah, did you have a question? Right. No, that's a excellent question. So we got Grayman asking, what if the staking platform goes down, right? Or what if, I just disappears, everyone's screwed? Like what if I just take down all my servers? Well, that's actually not going to be an issue because like I said, right, you're not trusting me with the data. Like I can't just magically change the data because all the mutations they're done by putting them through the contract, right? So if you have like some initial state, you have to put it through the contract to get the next state, right? So the contract's always the intermediary between state changes. So it's as secure as the contract is secure because this contract does all the checks it needs to do. And regarding the data, it's really cool because you can actually walk through the blockchain, right? Walk through all the blocks and you can always recalculate it, right? So it's not magic, right? The blockchain doesn't store the data, but it has like you can think of it as snapshots in time, right? So you can traverse through all the original snapshots and get back the current data, the most recent current state. So no, you're not trusting me, and you have as much security as the contract provides. Is that clear? Right, 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 right. Right. So the question is like, how can you recover, right? If the data is just all hashes, then what you can't recover, right? Because hashes are non-reversible. No, that's a great question. So off-chain, right, obviously doesn't store the hashes, right? So whenever you actually interact with the transaction, you're providing the actual data, like the actual data, not the hash, the actual data into the transaction when you build it and you submit the transaction. And the contract is actually what hashes the data. So you provide the complete open data, right? You're not hiding the data. And then the contract does the hashing and the checking. So like I said, like it does computation, right? The contract only does computation. So you provide the raw data and the contract just does hashing of the data. And this is possible because of yeah, so I have it in this slide here that whenever you do any staking, you provide the actual raw data, and it's done through something called the redeemer on Cardano, or on Ergo it's called a context aware, and it's the same thing. It's just data that anyone can provide into a transaction when you build it and submit it. Right, and there's some limit of data that you can provide into this, and we provide the actual data within this constraint, right? And when you do this, you actually publish that data is actually published on the blockchain, and but this is a really special type of like data where it's not actually in the context of the node, right? So the node doesn't know about like the like it doesn't save it for long term, but it does save it from like historical transactions, right? Just in the same way that the transactions like an address did, right? Like the address had an initial balance of like 1 ERG, and then a year later it has like 100 ERG, right? You can track that, right? So in the same sense, you can track this data in the redeemer or context variable. So really to summarize, you can get back the data by traversing historical transactions. So you're not trusting me at all. Yeah, did you have a question? Yes. All right, yeah, great. So, yeah, no, just to summarize, really, the contract is something that just verifies the integrity of the provided data, and that's really the general theme of contracts on the UTXO model. Contracts position really is just to verify all the data, right? It doesn't make new data. It doesn't do anything special. It just verifies, hey, is what the transaction builder provided, is that correct? Are they like lying about something, right? Because checking something is always far cheaper than actually making it from scratch, right? And I think that's really where UTXO shines because account model, right? It has to store all this data. I mean, sure, it's easier for developers, but these node sizes are ridiculous, right? I can't like run a 3 terabyte node in my basement, right? Just for Ethereum. And that's just Ethereum. You have all these forks, right? If I want to expand to multi-chain, I have to spin up like an Ethereum node, a Binance node, Polygon node, and so on, right? If I want to do the things the right way and not, buy like a subscription to an RPC, right? And it's not scalable, but in my basement, I can run an Ergo node, which has what, like 20 gigs, 30 gigs. It's nothing, right? Flash drive has more storage than that. And a Cardano node, right? Cardano node was like 160 gigabytes. Like I can run plenty of these compared to just one Ethereum node. So you can see the trade-offs here, they really shine when in the long run. So, really, the final slide here is improvements made to the original protocol, right? So, the original contract was short-lived and static. So, like I said, it was originally meant for like things like meme coins, right? So, where you just don't want people to sell, right? You don't really think about long term. And the problem with this was it was very static. So, you have one emission rate for the whole program. So what I also added to the staking contract, the protocol itself, not the UTXO implementation, is I made the emissions very dynamic. So like every epoch, so for example, on Palm staking, every week people can claim their rewards. This emission amount can fluctuate without, having to redeploy the contract or get people to migrate. And this is really cool because a dynamic protocol allows us to easily curb any excess inflation or it incentivizes staking during, like steep price movements. So it allows us for more of a fine-grained control rather than so we actually react to how the economy is doing, right? I mean, you saw yesterday that things went crazy. So maybe during a time like that, you want to incentivize people to hold, right? So maybe we'll tell them, okay, we can increase inflation so that people hold on to their palms of selling it on the market just for no reason, right? When everything's going crazy, right? So then people might not sell because they'll say, hey, like I can just put it in the contract. I believe in Palm. I believe in this token's future, right? I believe in crypto. So like maybe in next week, you're not gonna the tariffs are gonna be reversed, and we won't have an issue. So maybe I want to hold my Palm and make some more Palm and money instead of selling, right? So the dynamic protocol really allows for this. And yeah, that's it for staking. So hopefully that was a some presentation that you could understand. I tried to make it as least technical as possible so everyone can enjoy. So any other questions? Yeah, so it's quite technical, but you can think of on well, really on the actual usage wise, rather than in the data structure implementation wise. Um, Kushti mentioned that the AVL tree is actually a lot more efficient compared to the Merkle Patricia trie that you have on Cardano. And so meaning like the proof sizes, the really efficient means that you can do more operations in a given transaction, right? So the proof sizes are smaller. So what the data that you provide during transaction building, it's a lot smaller. So what does it mean? So that really, what does it mean for the end user? It means that transactions really will be cheaper But there is a significant implementation difference how it works internally. But I don't really know that from the top of my head, and I can't speak for it that much. But in the context of this, though, you can think of it as interchangeable. Yeah, Grayman. Right. Yes, so correct, correct. So Grayman brought up a great point. So yesterday, again, I don't think everyone's quite active on Twitter, but so there's a protocol on Cardano called Liquid Finance, and it's a lending protocol. And what they did yesterday was because of the extreme movement. So I think Cardano literally went from like 80 cents to like 27 cents in like a flash because of like mass liquidations. So Liquid Finance is a decentralized lending platform, right? So you provide some collateral in ADA and you get back an asset. So since the price moved down so steeply, you're going to have some liquidations due to that. So Liquid Finance completely shut off their front end interface, and you can't manage your liquidations now, right? No one can liquidate you or anything, and you can't make new collateral requests and so on. I don't know why they did this. I mean, obviously to protect people from being hurt, but like I don't know. I think everyone's like a grown man here and can handle their finances, so I think that's kind of silly, but it is what it is. So so yes, they disabled the front end, right? And maybe that I can make a custom transaction using code, right, to interact with like the contracts. But I actually found Cardano is very funny. Um, a lot of these off-chain runners, right? So basically, what processes your transactions with the main contract, they're actually permissioned. So for people to run the off-chain like bots, you need to have like maybe you have to be the owner of a certain address, right? So only your private key can actually run the transactions. But what's more common is like it's like a special NFT, right? So all NFT holders are the ones that can run these off-chain, right? That's a very it's not decentralized at all. It's just made on a decentralized platform. Yes. So really, this is a very simple check, right? Like you have a contract, right? And you're like, okay, all these calculations happen. It's decentralized, but you add just one tiny check. Only the holder of this NFT can run the transaction, right? So technically, no. For a lot of protocols on a Cardano, no, you can't just bypass everything and build your own transactions with code. I can't do that because I don't own that special NFT that you need to actually process the transactions. And no, this is actually like really bad. I don't know why it's like a very common on Cardano, but yeah, no, it's not really decentralized is the answer. Uh oh yeah. So oh really? Oh my God. Yeah, so very again, like as Joe kept mentioning, know your assumptions, right? Is something permission? Like for example, we have the hodler game, right? It's all open source. So if the front end shut off, first of all, you can just spin up your own front end because the code's all there. Second, you can build your own custom transaction and you can run your own off-chain because all that code's open source, right? It's not hiding anything, and you don't need any special NFT. Even even on Cardano, if these projects are all open source, even if the off-chain is all open source, the website's all open source, it doesn't matter because you need the NFT to actually run the off-chain, right? It's not literally not going to work. So it's decentralized, it's open source, but you can't do anything. Yeah, Grayman. Oh no, that's a great question. Maybe we can talk to Allison who's in the back. He's the Nautilus developer. But what Grayman said is like, hey, can we have a hodler natively within the Nautilus wallet itself? And I think that's really cool. Like maybe we can have like a dedicated like apps section on Nautilus wallet. I think it's already there with like SigUSD, but I think a bunch of apps within Nautilus, right? So you don't have to like go to any website, right? You're actually technically running your own front end, right? Because it's a wallet extension, so you're not even reliant on me hosting the website. So I think that's a great idea, and we can have like a bunch of apps on Nautilus, right? Just click like two buttons, and you interact with the protocol. I really like this idea because again, you're not worried about any front end, right? Or a front end can if a front end gets like hacked, what a front end being hacked means is that someone takes ownership of the domain that it's on, right? And injects like custom code. So maybe they made an exact replica of my front end. And then they're like, hey, when you click this like mint button, instead of minting, you're like transferring all your erg to an address, right? Like that's what a hack really means. So this isn't really possible if you have something running on like your own instance, like on Nautilus itself, right? I mean, it's only possible if you literally physically download a virus, and maybe the virus does some like magic where it has control of Nautilus. But in a general hacks, if my website gets hacked, that's not going to affect your Nautilus, which is running its own like app instance of like Hodler. So no, that's a wonderful idea. We should definitely get that going. All right, any other questions, comments? Yeah, go ahead. Yes, yes, it's live on Cardano, and yeah, it's called palmeconomy.io, and you can find information about it, and it's specifically staking for Palm token, which is the token for Zengate's Palmyra RWA platform. Cheese. So currently there is no plans to do it on Ergo. It's not up to me, right? But in the future, the point is that it's pretty straightforward, right? Because now that it's done on Cardano, everything maps directly to Ergo, right? So since all the theory studies, the theory, guys, is what takes a long time, right? Getting it done right, planning it out. Implementation is pretty straightforward once you have this theory, right? So that's why EVM is so successful because it's been there since what 2015, and you have so many contracts. So guess what? A new fork, a new L2 base has their own Coinbase has their own blockchain. You take the contracts and you copy paste it over. It's literally copy paste. So in a similar sense, since we already have everything ready on Cardano, when we're ready for Ergo, right, we can just take that code and translate it over to Ergo. So it's much more trivial compared to making it from scratch. So yes, it's all very similar, right? It's not exactly copy paste because on Ethereum it's literally a fork of the node. It's the exact same thing. So you can actually copy paste the exact code and deploy it on like L2s and so on. So that's not the case for UTX. So you can't copy paste it, but like the overall idea maps directly, right? So you're just translating whatever Cardano smart contract language to Ergo script exactly, right? So there's less friction. I mean, there's more friction than going from like Ethereum to like an Ethereum fork, but from like conceptually, it's like the same because the architecture's the same. Yeah, cheese. Yeah, I would definitely use AVL because it's built into the contract, right? They both serve like that same like abstract need, right? Of storing data off chain and then verification on chain, right? That's really the important part of like that's the only thing that really makes this work. So AVL tree does serves the same purpose. So there's no reason to having to use a Merkle Patricia trie on Ergo. So actually, no, it's already decentralized in the sense that you can traverse through like Ergo Explorer and you can get back that original data, like the non-hash data, and it's actually even better than IPFS, right? Because you don't have to do any like pinning or anything. So it's all there on Ergo already, right? But the actual raw data that you probably were thinking about is like the tree data and like the balance data. I know that cannot be stored on like IPFS or something because it's something that requires a database, right? Because you're doing database operations. Yeah, in the back. Oh, all right. All right. Any other questions? All right. Thanks for tuning in, guys.
Yeah, so hi everyone, I'm Luca, and I'm going to talk about Gluon W, which is a cryptocurrency stablecoin protocol. Um, yep. So just to start off, I just want to acknowledge the people that were involved with writing the paper. So the first is Bruno, who came up with the idea of Gluon. Um, then there's Mohammed Shahir, who did the formal verification, and he was a student at Carnegie Mellon University in Qatar. And then Giselle Reese, which was his supervisor. So it's the outline for the talk. So I'll just go over the different types of stablecoins, how Gluon works, uh, the main theorems, and then certain issues that we found while we were working on it, and then uh, future directions to solve those problems. So just basically, there's three main types of stablecoins so far. There's asset-backed, so like the big ones, USDC, Tether. They hold you have to trust them to hold a physical reserve. Um, then there's crypto collateralized, like DAI. So you put in collateral, and then the stablecoin you get is like effectively a loan, but the collateral you put can get liquidated if the price depegs, and that's like out of your control. And then there's crypto backed like JED, Gluon, and Dexy, and that just requires that the algorithm is properly implemented, and that in the case of UTXO, the off-chain executors don't stop working, so people can still interact with the protocol. So just a review of how Gluon works. Uh, there's four main actions that as a user you can do. Um, so fission is the act of putting in your base coins. So in the case of Ergo, it would be putting in and that'll spit out the stable coin, so the neutrons, and the reserve coin, which we call protons. Uh, then there's fusion, which does the opposite. So you put in the neutrons and protons, and you'll get your erg back minus a fee. And then there's beta decay reactions. So beta plus can convert your stable coin to a reserve coin, and beta decay minus can convert the reserve coin to a stable coin. And you pay a fee for these actions. Um, and then we just define so from the reserve ratio, um, which tells you it's like the factor by which the reserves are greater than your liabilities. You can define the fusion ratio, which is just the fraction of the reserves that backs the stable coins. And from that, we can derive like the stable coin price and the reserve coin price. And then, yeah, so I want to go into how these equations work, but basically, uh, when you do beta decay reactions, the protocol keeps track of the cumulative volume of the reactions over a certain time, t, and the fee you pay is based on this difference. Yeah. So the first important theorem is we want to make sure that the peg gets maintained. That doesn't so the price doesn't diverge, right? So when we're in the peg state, so the stablecoin price in that equation that I showed before equals the oracle price. We show that the price you pay is bounded within a certain limit. Um, and in order to derive some like meaningful equation for the case of the theorem, we just make some assumptions to make the calculations easier. So that the volume of your reaction isn't large, for example. And uh, when we mean like the price of buying a stable coin, so at the beginning I showed the reactions of fission, but that gives you protons and neutrons. So to just get neutrons at the end, you want to do a beta decay plus, where you'll take those protons from the fission and then convert them to neutrons. So then at the end, you only have stable coins. And it's a similar process for the other way around. So for selling, um, when you want to sell, you'll just have stable coins. So you're gonna have to convert some of them to protons and then do a fusion. And again, when in the case when the price is the peg is maintained, so the neutron price equals the oracle price, then yeah, the selling price is bounded by this effective fee. So this effective fee is so it takes into account the the two actions of doing a partial beta decay and then a fusion. So yeah, so just an aside. So in the case of buying neutrons, we also have this effective fee, which is like represents the cumulative fee for doing a fission and then a beta decay. With the given equations for the actions that we have in this protocol, it's pretty complicated to derive like a value for this effective fee. So that's why in the current implementation, if you go on the gluon.gold website, we don't do cumulative actions. Like you can only do each individual one for simplicity. In order to if we wanted to implement that to make it easier or more like to improve the UX, you'd have to derive it ends up being a polynomial equation for the effective fee because the beta decay fee depends on this effective fee as well. So you end up getting a polynomial, and deriving the coefficients for this polynomial is a lot of algebra. Then you have to write an algorithm to compute the coefficients based on like how many stable coins the user wants, then find the roots, and then the root is the value of the effective fee, and for that you can solve for m, which is how much erg data have to provide. And it's the same process for buying just one if you just want to buy protons, but it's a different equation, but it's the same process. And with selling neutrons, there's a slight difference because we have to because remember I mentioned that we have to convert some of the stable coins uh, to reserve coins and then do a fusion. So we have this like I call it the gamma factor, and that represents the amount of your initial amount of stable coins that you have to convert to protons. And so par- in in this case, our polynomial is about finding this value of gamma. And then once you find it, you can figure out what the effective fee is, and then uh, how much erg you can get if you want to sell and stable coins. And yeah, the process is similar for selling just protons. So a cool thing about Gluon is that it's resilient to price crashes up to a certain amount, and that's what this theorem wants to show. And it's similar to the Jet theorem. Uh, it's actually the same equation, except where there's a Q star, it was Q and Jet. Um, uh, yeah, so, and by the price crashing, we mean the oracle price. So if the oracle price goes down by some amount, then we can show that the neutron price, as we defined it earlier, won't change. And then another nice property is that the equity of the bank is always positive. So that's you don't want that to be negative. And the equity is the part of the reserves which, uh, as a proton holder, you have a right to. So if you just hold stable coins, you have a right to the total reserve amount minus the equity. And we show this theorem shows that basically the proton price always increases, assuming the price remains pegged, except in the case when you want to do a beta minus. So converting stablecoins to protons when the reactor is depegged. Yeah, so and I'll also explain why that happens later. So this is good as a proton. So it's like an incentive for holding protons because you know as if the bank stays pegged, if the price stays pegged, then uh like the price of your protons will go up. Um, so as we were trying to prove the theorems, we had to make some initial assumptions to make our derivations easier. And one of those was this lemma, which said that the absolute value of the change in volume was less than the reserve amount. Um, and if we assume this, then we could make some like simplifying assumptions. Uh, However, I wasn't able to find a straightforward proof of why it was true. And like I tried, but I wasn't satisfied with what we had come up with. And yeah, eventually I found a counterexample. It's kind of funny, which is you basically um, start off with some amount of protons, and then you so you also assume that uh, like we're using real numbers, so you can like divide them infinitely and so on. Uh, and then you just divide by two, and then convert those protons to neutrons. Um, and then you'll have a leftover amount of protons, and then divide that by two and convert that to neutrons, and then do that over and over again infinitely. And then you can see that the volume of the reaction actually ends up exceeding the reserve amount for for if you use like the correct values of the variables in the equation at the bottom. Yeah, so this meant this lemma was false. Um, but luckily, in the first and second theorems, we don't actually end up using it. Um, yeah, and this is a theorem that was true in JED, but isn't in the case of gluon because you can always mint more protons. So your share of the equity can decrease since more protons can um, get into circulation. Whereas in JED, the amount that got minted was bounded by a certain amount. Uh, this would be a nice theorem if it was true. Like it would be a nice property to have, but in the case of gluon, it's not. So it is possible for a bank run to happen because when so as I mentioned before, to sell your stable coins, it's like the you're combining two actions, right? You're doing a partial decay, beta decay, and then a fusion, but that beta decay fee depends on the volume. So the more people sell, the higher this fee will be, and so the next person will have to pay more. So they're incentivized to sell as early as possible. However, because this fee increases so much, at a certain point, the fee is so high that it's pointless to sell. So you can wait that amount T, which is a protocol property, and then wait for the fee to go down again, and then you could sell at that point. Um, and this is another important theorem which we would have liked to be true, but was unfortunately false, is the no reserve drainage. Um, so basically, this says that, so ideally, you would want, because of the fees you pay, the total value of the assets you have before an action should be greater or equal to the total value after. So, and by value, we mean the amount of base coins you have. So, for example, ERG plus the amount of stable coins you have times the price. So those, so why that product is because those units match the units of base coins. So it's like represents like the volume of stable coins you have in units of, in our example, ERG, and then the same for protons. So you want this value to be greater than the amount after the action. However, there's this funny thing that happens when the state is depegged. In the case of beta plus and beta minus, if this like a difference in the case of beta plus if it's positive, then this won't be true. So what that means is that you could uh, you could sell your protons, but then the proton price increases, which doesn't make sense. And so all of these problems that I mentioned, they're related to the fact that before in the beginning of the presentation, I showed the equation for the fusion ratio. It was the minimum of this parameter Q star and this ratio. And this ratio is what we call like the reserve ratio. So the reserve divided by uh, the oracle price times the number of a circulating supply of stablecoins. But then we take this value and then obtain a what we call a normalized reserve ratio, so that when it's above the cutoff ratio or R star, it's just equal to the reserve ratio. So the in this plot, it's like the straight line. Um, but then once it's below, so in the deep state, we do a min function so that it just becomes this constant number and hence the flat line. So because we define it this way, this flat line causes all of these problems. So how could we fix the issues? Well, first is instead of using a constant function um, for the normalized reserve ratio when the reactor depegs, we use a linear function um, so that it goes to the initial value is 1 and it just decreases smoothly. Um, and we could make this single modification to the current version of gluon W while keeping everything else the same. But we could also improve the volume equation to make it easier to calculate in the smart contracts, and because it's easier to implement. And even though we can derive equations for the effective fee, in order to avoid these complicated calculations, we could just restrict the amount of volume that's allowed uh, for a given transaction, and this will make composing reactions easier, and so we'll be able to improve the UX. Yeah, and that's it. Yeah, so T itself it's like a protocol parameter. So you define that ahead of time before launching the stablecoin. So in the case of Gluon Gold, it's 14 days. So in I'll go back to the volume calculation. So um, what I'm trying to so let's say you do a beta gate reaction now. You want to calculate the cumulative volume of reactions in the interval between now and now minus t. Yeah. Yeah. So uh, So with respect to theorem one, theorem two, the point of those theorems is also to show that it's you, you assuming everything with the blockchain works properly, it's always more cost effective to purchase and sell stablecoins from the reactor itself than from a secondary market on a DEX. So you're always going to end up paying more if like there's a liquidity pool on Ergo DEX with Ergo and Glue on Gold, right? It'll be cheaper to buy directly from the reactor instead. Yeah. Yeah, so current in the current like if on the website because we have implemented the only the actions separately, you'd have to like calculate the fraction. You'd have to convert to protons to then do a fusion to get back your erg minus phi. Uh, so it's not like the most. So the UX is not that great, but that's like the process effectively. You can always redeem back your base coins minus a fee. Um, so I'm a bit confused. Yeah. Uh, I haven't checked honestly. Yeah. Uh, but the website says how I'm like if you go on Gold, you can see how large the reserve is. I think there's like 10K or yeah, a little over 10K erg inside the reserves. Uh, yeah, so let's say you do a fission, right? You'll have stable coins and protons. So if you just hold protons, um, if the price of erg goes up, then the price of your protons increases. So you can get more erg. You can then sell your protons and get more erg from the reserve. And so I can explain why. So um, if the price of so in the equation for Q, you can see the oracle price. If the price of erg goes up, then the uh, oracle price goes up, right? And Q will increase. Uh, oh wait, No, that's wrong. Um, oh, sorry, no, I'm confused myself. Sorry. Well, no, polynomial, not differential. Polynomial. Any other questions? Okay.
Thanks everybody for watching so far. We've got after lunch, we've got Karat, we've got Cannon, Mark the Shark, and Anon BR. They're taking a short break for about 45 minutes for lunch, and they will be back with that after. We will leave the stream up, and we'll see you then, guys. Thanks. We are getting ready to start again in a few minutes.
All right. Okay, so I am a cheese enthusiast or Karat, and I've been working on Lithos, the future of proof of work mining. So let's talk about the goal of Lithos. And so the Lithos team has a vision of bringing transparency and decentralization to proof of work mining. And specifically, this is related to mining pools. Now, mining pools have existed for a while. They are just a way for miners to essentially come together, take all of their hash rate, and produce blocks in a way that allows them to get consistent payments. Mining pools are currently quite centralized, but there have been attempts to decentralize pools in the past. One attempt that I worked on previously was smart pools on Ergo. If you remember getblock.io, we worked on a way to essentially uh, make the payments of mining pools completely transparent. Now, smart pools was a novel technology at the time, but we found that there were still many centralized aspects to mining that could not really be solved using the sort of setup that smart pools had. For example, the pool operator inside the smart pool system had full control of the back end. They could change whatever they wanted in terms of what a miner worked on, like their shares, or how much they got paid. They also had complete control over the block production. For example, the transactions that go into the block, any storage rent that was claimed from the block, etc. So the goal of Lithos is really to try and to centralize all aspects of the mining pool and make sure that miners can mine to pools in a way that still allows them to get their consistent payments, but at the same time, do it in a decentralized manner. So let's talk about centralization in proof of work mining. So mining pools in general, obviously they have some benefits in terms of allowing more miners to enter the mining space with less hash rate and then therefore get more consistent payouts. But uh, proof of work mining pools haven't really been perfectly decentralized and they have a lot of issues associated with them. So it started as a decentralized process where individual miners competed to solve these complex mathematical problems. It's turned into a centralized system where the largest mining pools have significant control over the network and can potentially manipulate it for their own benefit. For example, while it may not necessarily be likely, mining pools could perform 51% attacks on the blockchain. They could also act in bad ways to get rewards from miners that they're deserved, or they could even change what transactions go into the block that is being mined. And that way they can censor certain transactions. You may have heard about this happening on Ethereum, for example, where certain mining pools ended up censoring transactions to Tornado Cash, which was seen as sort of a bad thing because it's about mixing the cryptocurrency and preventing people from figuring out where the cryptocurrency came from. So in general, mining pools have a lot of power and they're able to do all these things like censorship, potentially steal rewards, etc. So the concentration of power in the hands of a few large mining pools is a serious problem. And it kind of goes against the vision that Satoshi Nakamoto had when he originally came up with the idea of proof of work and its application in blockchains. So proof of work today is still very important. It's still widely used as a consensus algorithm in the cryptocurrency industry. But with the introduction of mining pools, it has fundamentally changed. It is much more about the mining pools and the power that they have rather than the individual miner and what they're able to provide. And this has introduced significant risks to the security, decentralization of various networks. I'd say the main issue is really that mining pools have complete control of payments and block production. So payments obviously is about how miners get paid for the work that they produced while they were mining a block. Mining pools have complete control over this and that they can essentially go into their database, see whatever shares that a miner produced, and they can change it on the fly to whatever they want. So if, let's say, a mining pool has some sort of personal vendetta against a miner, they could theoretically give that person less rewards. Additionally, mining pools have complete control over block production. And block production is really important, in my opinion, because it is essentially the way for miners to insert their own transactions or allow whatever transactions they want while they're mining to the chain. Mining pools have complete control over what goes into the block and what kind of transactions are allowed. As I referenced earlier, there was a whole Tornado Cash scandal on Ethereum where certain blocks were censored when they contained transactions from this Tornado Cash app. And this kind of really goes against the whole, idea of decentralization in the first place. We want people to be able to essentially submit whatever transactions they want, have them picked up, and then put on the blockchain. Censorship from mining pools goes against this completely. So the goal of Lithos is really to handle these two problems. Make sure payments are completely decentralized and make sure block production is in the hands of the miners themselves. So what are we solving? So the first problem are mining pools are black boxes that are lacking transparency. They hurt decentralization in this way, and they have some history of being bad actors within proof of work cryptocurrencies. So to fully solve this problem, we have to fully decentralize mining pools and place them onto the blockchain using smart contracts. So by doing this, we ensure transparency, we ensure fair payouts, and we really empower the miners to do more versus the pool operators who may not necessarily have the best interests of the blockchain in mind. We also ensure like a more efficient flow of capital from the coin emission directly to miners without presence of middlemen who can manipulate the fees without any rules. Now, our second problem is that mining pools require trustless and fair distribution. Um, in normal mining pools, rewards are distributed to miners by keeping track of partial block solutions, also known as shares. Mining pools keep track of millions of shares. They have databases usually that essentially keep track of each miner's shares and how many shares they submitted during the mining process. When a block is found, mining pools look through the database and decide how much work the miner produced for the mining pool in order to determine how much they got paid. Now, we want to decentralize mining pools, but on the blockchain, we do not have the storage capacity to store millions of shares. It's just not viable. It would cost too much. So, in order to solve that, Lithos came up with this idea of the non-interactive share proof. So non-interactive share proofs are essentially a way to compress the amount of work that a miner produced into a small handful of shares. And then that handful of shares can be verified on the blockchain using various smart contracts to determine how much work a miner produced over a certain period of time. Non-interactive share proofs, or NISPs, are used throughout Lithos, and they're used to ensure that miners are paid fairly according to the amount of work that they produced while a block solution was being found. NISPs are computationally very simple to evaluate and determine whether or not a miner is lying about how much work they produced. Additionally, storage-wise, they do not require a lot of space on the blockchain. And in a place where space is very limited, NISPs are able to compress the amount of data and make sure that costs associated with the mining pool itself are not too high. NISPs themselves are essentially a collection of around 10 shares with high difficulty that are used to determine how much work a miner produced. They do this through concepts borrowed from NEPA actually, specifically the concept of goodness and the idea that when a person is mining over a large period of time, it is almost certain that they will produce a number of large, high difficulty shares throughout that mining process. NISPs use this idea to essentially prove that a miner performed work by checking whether or not they produced those high difficulty shares. Now, in order to store NISPs on the blockchain, they are very small, but still, we want to be, when we're dealing with smart contracts, we want to be as efficient as possible, space and computation wise. So the current idea of Lithos is to use an optimistic rollup to evaluate each NISP and ensure that while computation isn't too high, we can still ensure that people are being provably fair and are being paid according to the actual amount of work that they're producing. Sorry. So decentralizing mining pools requires ensuring that there is some amount of censorship resistance. Now, on Ergo specifically, the Coinbase transaction has been made so that it must go to the public key address of whichever miner mined the block. So in order for censorship resistance to really be possible on the Ergo blockchain, we need to do what's called collateralizing the erg. And what I really mean by that is to provide an amount of erg equal to the block reward before the block is mined. Now, when the block is mined, that erg amount given by the lender is distributed to the miners as the block reward, while the actual block reward, which goes to a certain public key address, is given to the lender's address instead. So in this way, you essentially allow for miners to create their own block, set the public key reward address of the block to the lender, and then allow the actual payment to instantly go out to all the miners whenever the block is verified. So this is important for a few reasons. For one, it does allow censorship resistance in the sense that any miner can mine their own block while still ensuring that the reward of the block goes to all other miners in the pool. It's also very useful in the sense that uh, when you're normally mining on Ergo, there is a certain 720 block wait that you must do before the block is confirmed. And during that wait, nobody is able to be paid. Collateralization essentially kind of cuts through this process. It allows miners to be paid almost instantaneously whenever the block is found. So we want to ensure that we have these collateralized mining pools because we want to ensure censorship resistance. We want to avoid these problems like I called back to before, like with the tornado cache issue. We don't want mining pools to censor certain transactions. That is really one of the core goals of Lithos, to ensure that miners have complete control over the blocks. And giving control to miners over block production, that also allows miners to gain more erg. They're able to add storage rent transactions specifically for Ergo, and they're able to produce erg through MEV. And MEV was a big part of the reason why Ethereum, while it was proof of work, was able to gain so many miners. MEV allows miners to gain additional rewards through smart contract interactions, indexes, stablecoin contracts, etc. And we want to be able to bring that to Ergo, but give that power of choosing what actually goes into the MEV to the actual miners themselves versus the mining pools. So one important aspect of collateralization is that we don't want to prevent miners from immediately joining our decentralized pool without having erg. Now, if we force miners to collateralize themselves, that means, let's say a new miner comes into the Ergo ecosystem, they have 0 erg in their wallet, and they want to join a Lithos pool. If they have no erg in their pocket and collateralization requires at least an erg amount equal to the block reward, then this kind of clashes with the idea of any anonymous new miner being able to come into the system and provide work to the Ergo blockchain and then secure it. So Lithos specifically has focused on third-party collateralization, and that means that people outside of miners themselves are able to provide erg to the mining pool to collateralize the block, and that would allow new miners to join without having any erg at all, and therefore mine on this decentralized pool without having to put up some amount of erg that they may not already have, right? Collateralization also allows people outside of mining to gain erg by using pool fees in a way that is contractually obligated to not be sort of suspicious. For example, like a normal centralized mining pool may be able to adjust their fees any way they want. Lithos mining pools, the fees will be determined by the smart contracts, determined by the market of collateralization itself, by all of these lenders who want to provide ERG to the blockchain to help secure it. This also goes into the Lithos token. Now, Lithos token tokenomics are not particularly set yet, but the general idea is to incentivize miners to mine using Lithos and allow them to gain additional rewards despite the pool fee that they pay to the collateralizers. So let's go into some of the more technical aspects of Lithos now. Um, Lithos protocol is an advanced decentralized mining pool protocol. There have been some mining pool protocols in the past that have been somewhat decentralized. A few examples that I can name is P2Pool on Monero has been running for a while. And that is essentially a sidechain on the Monero blockchain that allows miners to mine to this sidechain and then gain rewards of Monero. Now, it is decentralized. However, it faces a lot of problems in that block production is still not entirely on the miner's hands, as well as rewards are a little bit obfuscated. It doesn't help that Monero is a completely private blockchain, but essentially it's not the most ideal solution. Now, we've had smart pools on Ergo as well. These were a good idea, I think, but they didn't fully decentralize the entire process of mining. There was also another smart pool initiative on Ethereum while it was proof of work. Um, it was also quite decentralized, however, it lacked efficiency. And that's something that is really important to us at Lithos. We want Lithos to be scalable. We want it to be able to potentially handle hundreds of thousands of miners at once. And past solutions to decentralized mining haven't been able to do that. So the first technical aspect, and I've talked about it just recently, is collateralized mining pools. And we want collateralization to essentially ensure that block production is in the hands of miners. We want miners to gain MEV rewards. We want miners to be able to have control over their storage rent. We want to avoid censorship of any transactions at all. And another technical aspect here is the non-interactive share proof, which is really, I think, this is the most important part of Lithos, and it completely changes how mining is done. Mining traditionally on a mining pool, you get your mining software, you connect to the stratum, and you produce hundreds of thousands of shares over a period of time. The mining pool takes these shares, they store it in the database, and they determine how much work you did by looking at the amount of shares multiplied by the difficulty that you mined at. And obviously, this is not good enough for a smart contract. It just takes too much space and computation. So NISPs are the alternative, and they ask sort of a different question of the miner. Instead of asking how many shares did you produce over a period of time, we're asking, can you produce, say, 10 shares at a high enough difficulty to prove that you did a certain amount of work at while the block solution was being generated. And this kind of change of the question has a big implication in terms of how mining works on Lithos. You're not going to be mining in the traditional way. Obviously, you'll still have a mining software, you'll still have a stratum that you connect to, but the way your rewards are calculated are completely different. You are not simply adding up the number of shares and then dividing it based on the total number of shares produced by the pool. You are essentially proving that you did a certain amount of work by producing these high value shares. And then that allows you to store all this data in a small space. NISPs also are very important because they are computationally efficient and they're efficient storage-wise. We can use optimistic rollups to allow for greater scalability with the smart contracts that we're using. Now, an optimistic rollup, you can think of it as a layer 2 solution that is essentially, it's taking all of these NISPs and it's assuming that each NISP is going to be completely successful and valid unless it is checked upon. Now, in Lithos, we plan to have lots of off-chain bots that will be checking each NISP submitted to the blockchain. And if a NISP is found to be fraudulent, a fraud-proof transaction is submitted and that NISP is removed from the equation. Now, this is really important because we're not evaluating each share proof on its own. We're only evaluating share proofs when we know they're fraudulent. And what I mean by that is we're not evaluating share proofs on the blockchain. Obviously, evaluation is happening off-chain, but we're really focused on on-chain evaluation because that is what is costly. And fraud proofs allow for us to minimize the amount of computation on-chain while allowing the majority of computation to happen off-chain, where computation is easy to do and there are way less limits regarding data and space. There will be incentive to submit fraud proofs. Now, usually with rollups, we have what are called sequencers. And sequencers can be kind of thought of as people who are submitting their rollups to the smart contracts um, and then getting some kind of reward for that. In Lithos, we want everybody to potentially be a sequencer. And a sequencer is kind of equivalent to like a pool operator um, in that they're the ones getting the shares and submitting them. Now, obviously, we want individual miners to have the power in Lithos, so anybody can be a sequencer, potentially. But in general, there will be some limits because obviously, if we allow anybody to be a sequencer, then um, there's a classic problem with blockchains in that people can spam the blockchain. Um, so there will be some limits in regards to who can be a sequencer, but the general idea is that the limits will be low and that people will be able to become a sequencer with a certain amount of tokens and then submit these transactions to the smart contracts themselves. All right. So another important aspect of Lithos is that, oh yeah, no problem. Sorry, can you repeat that? Like, mhm. Oh no, absolutely not. Because the difference is that when I say a high difficulty share, the difficulty or the high difficulty is relative to a difficulty the miner themselves chooses. So if I have, say, like my shitty laptop right here, and I decide to mine on it, obviously I can't produce many high difficulty shares. I just don't have the computational power to do that. But on Lithos, you choose your own difficulty. You choose what difficulty you mine at, and um, that means that a high value share for you is different than a high value share for somebody with 20 GPUs in the back, for example, right? So when I say a high difficulty share, it's relative to your own computational power. And this is important, and I'll get more into it later about how your difficulty is chosen and the kind of effects that has on your payouts, how much you get paid, and how often you get paid. Now, for Lithos, the usage of non-interactive shared proofs means that it is essentially completely blockchain agnostic. So non-interactive shared proofs are really only evaluating the difficulty, which is sort of the value of the share or how high the actual number is compared to the target value that the blockchain wants you to find when you're looking for a block. Because we're only using math essentially to determine whether or not you did work, it's completely blockchain agnostic. And what that means is that you can use NISPs on something like Bitcoin, something like Litecoin, other proof of work currencies, Caspa, Lithium, all of these currencies which are using traditional proof of work algorithms. You can use NISPs to evaluate how much work somebody did. And what that means is that we can have smart contracts on the Ergo blockchain, which allow you to mine in a decentralized manner while still mining to Bitcoin. So you can mine Bitcoin while mining on a decentralized pool. Same with Litecoin, same with Caspa. So ideally, the collateralization in that case would work using wrap tokens, for example, from Rosen. So in that case, you would have wrap tokens that are paid to the miner on the Ergo blockchain, while the actual block reward would have to go to somebody on the initial blockchain, for example, Bitcoin, and that lender would have to be somebody from that blockchain, essentially. So it would be a little bit more complicated, and it would require some support from, for example, a bridge like Rosen to completely successfully do, but it is completely possible. All right. Now, I mentioned the Lithos token earlier. Now, lenders who provide collateral uh, will be using the Lithos token to essentially provide that collateral, and that would allow miners to it would allow a sort of proof of work economy to occur because miners on Lithos will be mining, just for example, ERG, and they'll be also gaining these Lithos tokens at the same time. And those Lithos tokens would be used by lenders to essentially lock in their collateral for miners to use. And the idea behind this is to essentially stimulate a healthy economy between people who mine and people who don't. And it would allow people to essentially gain money without having any computational power, which is usually not possible on a proof of work blockchain. It's hard, like on a proof of work blockchain, you can't secure the blockchain and gain, you can't secure the blockchain without some computational power, usually. But the idea of Lithos is to have people who are not associated with the mining world necessarily to still help decentralize the blockchain itself. Yeah, exactly. It is similar to staking, but it's a little bit different in the sense that it's not really percentage based in the sense that having more tokens will necessarily get you more. Um, but it's still a way for people who are not involved in mining to gain some money uh, while still securing the blockchain. Um, I mean, I don't think it should be any issue between Rosen and two miners, or sorry, Rosen and Lithos. What do you mean by two miners though? Oh, no, no, no. No, I don't think so. I mean, the way Lithos is working is just a normal stratum. So you can do anything that you do with your normal mining pools as long as it works with a stratum. So I know some people do dual mining, for example, where they partition part of their hash rate to, say, Bitcoin and some of it to Ergo. Um, you could do the same thing on Lithos without any real issue. Uh, we're using Stratum to allow things to be compatible in a way that doesn't require miners to update too much. You don't have to upgrade anything. You don't have to change your general setup, uh, but you're still able to benefit from the general idea of Lithos itself and the decentralization. So let me explain it. So when somebody mines or somebody's producing a number of hashes over a period of time, um, we can mathematically prove that somebody producing a certain amount of hashes over a period of time will almost certainly produce a certain number of high difficulty shares while hashing. So what that means is that while they're producing all of these random hashes, there's all random numbers. So for, let's say that person produces these hashes over the course of an hour, they will mathematically produce a certain number of high number hashes that has to be that will be present inside their set of hashes that they produced. So Lithos is taking advantage of that fact that they mathematically will produce those number of hashes to prove that somebody actually produced or actually did a certain amount of work. So if I'm a miner and I want to get paid on Lithos, but I didn't actually do any work, right? I I just want to say that I mined for 12 hours straight and I produced all these hashes, um, but I actually haven't done the work myself. To prove that I did the work, I would have to have a certain number of high value hashes that I could show to a smart contract to show that I actually did the work. But if I'm lying, I wouldn't have those high value hashes in the first place. They wouldn't have existed. So that's the general idea of a NISP, is to use the fact that high value hashes will be produced over a certain amount of time and that they will be produced at a certain ratio relative to the number of hashes that I did throughout the period of time. If I'm lying, I won't have those high value hashes to present to the mining pool, and therefore it'll be quite easy for somebody to see that I'm being fraudulent. Yeah, exactly. And there are obviously other aspects that must be verified. For example, um, I don't want to accept high value hashes that were produced like a year ago, right? I need to make sure that the timestamp on these block headers is valid for the block that we're mining. I don't want to have a hash from 2 years ago if I'm mining a block from an hour ago, right? So there are other sort of qualifications that need to be met for a NISP to be valid. And these are all checked through these fraud proofs on the rollup for the Lithos protocol. Does that answer your question? Right, exactly. Exactly. That is all decentralized in smart contracts, yes. The logic itself, so the logic itself is being run off chain, right? We don't want to have that computation of checking each and every share inside the NISP. That would take a lot of time. We're doing the logic off chain, we're checking each NISP off chain, and if we find an issue, we're producing a fraud proof on the blockchain to ensure that that fraudulent NISP is taken off of it. And there's a certain value of incentive to do this, right? If I'm a miner, I don't want some other miner to take some portion of my money because they produced a fraudulent share, right? So if I'm a miner, I am therefore incentivized to make sure that each share on the on the Lithos protocol rather is valid and not fraudulent, because I want my block reward to be maximized. Remember, block rewards are being separated between each miner inside the pool. So if I remove a miner who was fraudulent from the share of the reward, then I get more of a reward proportionally for myself. So there's a certain incentive to make sure that miners are always checking each and every NISP that is submitted to the Lithos protocol to make sure that they get paid maximally according to their work that they produced. Make sense? All right, cool. So let's talk about the testnet now. After around 1.5 years of work and the release of Ergo 6.0, the Lithos testnet is nearing launch. The testnet serves as a way for miners to try out all the new aspects of Lithos, and it's also to help me find any bugs that were produced during this process. Already found a lot of bugs while I was developing it, so can't imagine how many bugs will be there. But really, the goal is to try and iron out all of these issues before before anything gets released to the mainnet. So now, tying back to what you and Benzel and were talking about, mining on Lithos is going to be a little bit different to traditional mining. Now, for one, Lithos or the Lithos client is providing a local stratum for you to mine towards. So what that means is that your stratum or the pool that you're connecting to is going to be locally produced. That means there's never a chance of stale shares. I don't know if you've mined before, but stale shares happens when the latency is too high and the difficulty that you're mining at is not equivalent to the difficulty that the pool wanted you to mine at. So when that happens, it's just lost money, lost work for you, right? So having a local strata means that still shares are not going to happen. Additionally, miners on Lithos are solving a different problem. And this is going back to NISPs and how they work. So let's talk about difficulty now. So normal mining pools are asking the miners to send a certain amount of shares at a set difficulty. So if I go on, for example, here are miners today, I'll go on their 4G port and I'll be producing shares at the value 4G. So 4 times 10 to the 9, I think, is the value that I'm trying to produce shares at. And I'm submitting any share above the value 4 times 10 to the 9, right? Now, this is not viable, as I've said, on a blockchain. So Lithos is instead using NISPs. And NISPs are really asking a different question. Can I produce, now for Lithos right now, we're using a value of 10 shares. So the question that Lithos is asking is, can I produce 10 high value shares relative to the difficulty that I chose? And if I can produce those 10 shares, then I did produce a certain amount of work at that difficulty. So using this allows us to make things more efficient, make it more computationally efficient, more storage efficient. And it also changes how you mine. So as I said before, on Hero miners, I'm mining at a set difficulty of 4G. Miners with different hash rate than me, they're probably mining at that same difficulty. I could have 100 mega hashes, or I could have, let's say, 10 gigahashes of hash rate, and I would still be mining on the 4G port. On Lithos, it's completely different. The difficulty that I'm mining at is relative to my own hash rate. So if I'm mining at, say, 100 mega hashes per second, I will be mining at a different difficulty compared to the person with a mining farm who's mining at 20 gigahashes per second. And what that means is that between the two of us, we need to produce different value shares to prove that we performed work at our difficulty. So let's say I'm mining at 1G, for example. Maybe I need to produce 10 shares at 5G to show that I performed work at 1G. Now, if I have 20 gigahashes of hash rate power, I might be mining at, say 20T, I think is the next one. I'm not sure. Like, let's say I'm mining at 20T, then I need to produce 10 shares at like 50T. So the meaning of this is that the difficulty that you choose is directly tied to how much you get paid, because the difficulty is your way of showing that you're mining at a certain hash rate. So this has some effects on how you're getting paid. So for example, so yeah, that is important. So the time scale for Lithos is relative to the usually some set period of time before the block was found. Because when the block is found, all shares are submitted and then they're evaluated. So we don't want miners to kind of lie and say, oh, I produced 10 shares like 2 weeks ago and a block wasn't found until now, but my 10 shares are still valuable. They're not really as valuable generally. So we want to take shares that were produced within a certain period of time before the block was found. For example, let's say 12 hours before the block was found, any you need to find 10 high value shares produced within that 12-hour period and then submit them when the block was found to show that you performed work while the block solution was being generated. And this essentially prevents people from lying about when or about what work they performed and when, right? We don't want people to have, fake shares that are coming from the future or shares that are no longer valuable from the past, right? We want the shares to be produced while the current block was being mined. Now, because you're able to choose your own difficulty on Lithos and you're able to determine what difficulty you want to mine at, there can be some, let's say, funky things that happen if you decide to stray away from whatever the Lithos client gives you. So the Lithos client will look at your hash rate and it'll give you sort of a set difficulty relative to your hash rate that you can mine at. Now, you're free to change that difficulty value to whatever you want. So let's say I want to be a little bit risky, right? I want to maybe gain a little bit more money. So what I can do is I can set my difficulty value higher. And what that means is that my payments will not be as consistent. The reason for that is at my hash rate, I will not be able to reliably produce 10 high value shares for that difficulty. However, because my difficulty is related to how much I get paid, if I do produce 10 high value shares, I get paid more versus me mining at my normal difficulty. Exactly. You're trading your consistency of your payments for the potential reward of how much you get paid. So that can happen if you increase your difficulty. Now, lowering your difficulty, in general, it doesn't actually have much value because lowering your difficulty, you're just lowering your reward. And if you're already getting paid consistently enough, then it's not that useful. Now, if you're having trouble with payment consistency for some reason, then you can lower your difficulty and get paid consistently more often while sacrificing some amount of reward for that consistency in the first place. This is, I think, is a little bit foreign to, I guess, most miners probably. It's not really the traditional way of mining. Usually when you mine at a set difficulty. The number of shares is um, sort of proportional to how you get paid. Here, it's all about the difficulty that you mine at, and changing that difficulty will change how you get paid. How much you get paid, how often you get paid. So you're able to play around with this. Maybe you're feeling risky one day, want to increase your difficulty and you get your big payout. Or you increase your difficulty, you don't get paid for 3 days and you go back down because you feel like you didn't get anything out of it. So the Lithos client will be the main way for miners to interact with the testnet. I want to put instructions out for the Lithos client, ideally at the end of the month. Still working on currently the HTML UI for it. Currently, it's just a terminal UI that you could type in certain commands into. But I understand that most miners may not necessarily want that. So I'm working on an HTML UI, sort of akin to how the node works. If you've ever run your own node, there's an HTML panel that you can connect to where you can put in certain commands. The Lithos client will be pretty similar to that. So the current testnet, my goal is to release the testnet the week of November 2nd. Really, the last thing I'm working on is these interfaces, the HTML interface, and some of the off-chain code to sort of tie everything together. We have a lot of the contracts done, a lot of the code related with the contracts done, as well as a lot of the Stratum code done. Now, the current Stratum that is being used in Lithos, it is a completely new Java-based Stratum. Worst thing I've ever worked on in my life, by the way. So hard to do for no reason. But so right now it's only supporting 2 miners, Wriggle Miner and NB Miner. My goal is to start supporting more miners like Team Red Miner, SRB Miner, etc. But those will happen probably as the testnet goes along. With the initial release of the testnet, we're going to be supporting just those two mining softwares. Uh, but yeah, that's really it. That's the presentation about Lithos. You guys have any questions? uh, yeah, yeah, right. So Lithos client, the current way I have it is that there are a few options. Right now, it just automatically can build the block for you. And what that does is it really takes whatever transactions with the highest fees are inside the mempool. It takes those transactions and it puts those inside of the block. MEV is obviously possible. It's not currently supported in the testnet, but it's definitely very easy, I think, to implement. It would probably require using the HTML UI that I'm creating. Or there could be certain presets to try and get more value out of, for example, Ergo transactions, right? Additionally, storage rent is automatically claimed by the client. So any storage rent UTXOs that are available to claim at the time of the block will automatically be claimed and given to the miner of the block. All right. Yeah, so in general, that's really how the transaction selection block production works. Yeah. Right, right. It is currently it's prioritizing max fees. So if you're not putting in transactions with high fees, then get the hell out, you know? Right. Exactly, exactly. And miners can also plug in their own transactions, not necessarily MEV itself, but let's say you want to I don't know, maybe you want to fund some Ergo raffle contract or something, right? But you don't want to wait for the mempool to go through. You can put in your own transaction while you mine your block, and it will be put inside the block without having to pay any transaction fee because you're the one who mined it, right? So that's also possible as well. Yep. With merge mining, you said? So merge mining, it should be actually the same because the way merge mining usually works is you have your mining software and it is connecting to various stratum pools. And Lithos protocol itself is its own stratum, um, has its own stratum connection that you can connect to. So if I want to merge mine like Zcash and Ergo, for example, I can um, I can mine to both of them, have the different stratum addresses inside my mining software config, and it'll work normally, essentially. There shouldn't be any big difference. That is probably true, but you can adjust your difficulty to exactly, yeah. You'll have to adjust your difficulty to a lower amount so that you can find high value shares according to whatever hash rate you're mining at. So obviously, yeah, when you're merge mining, you won't have as much computational power, but you can adjust that so you still get paid at a consistent amount and for a fair value according to the amount of power you're putting in towards ERG. Oh, yeah, absolutely. It can accept Babel fees. Okay. I kind of get what you're saying. I guess for chain agnostic things, it would there will have to be at least one transaction on the opposite chain. Uh, so yeah, yeah. So I guess that transaction will probably be required to pay some sort of fee, and that would be by the lender who's collateralizing on the other blockchain. But for example, the Rosen, like the actual payments which are being done on the Ergo blockchain, that can use Babel fees for the payouts going to each miner on the pool. Um, mhm. So right. So the incentive is a pool fee, right? However, I think the difference is that at least the current idea for collateralization is to have it be an open market. So because miners in the end are the ones producing the block at their local machine, they're able to choose what public key address the mining reward goes to. So what that means is they're able to choose what lender they want to receive the reward and therefore the pool fee itself, right? So essentially, you can think of it as an open market, and whoever's providing the best fees is that's who miners are incentivized to choose for their collateral. And that means, like, let's say I'm a lender who is providing 35 ERG as the block reward, right? And I'm taking a 2% fee. The miner could look at all the other collateral UTXOs out there on the blockchain, and they can find one that's maybe for 1%. They'll use that instead. So it's in that way it ends up being most likely standardized at a certain level, and lenders obviously have some incentive to try and increase the fee, but at the same time they're also requiring the Lithos token, which is coming from miners. And in that sense, the idea is to have a sort of balance and a sort of proof of work economy that um, allows lenders to provide their ERG and gain additional ERG back, while allowing miners to sell their Lithos token to these collateral providers. So I think that is theoretically possible. However, one thing to keep in mind is that as miners gain more ERG, they can collateralize the ERG themselves. So then they don't have to pay a fee for themselves. And then at that point, you're almost always incentivized to use your own collateral if you have the ERG for it. So third-party collateralization is mostly for miners who don't have the actual ERG amount to collateralize themselves. And this is for new miners who have never mined inside the Ergo ecosystem before, etc. Right? Um, so in that sense, that's what third-party collateralization is used for. Yeah. Right. Right. So like if you, for example, if you've ever solo mined a block on Ergo, you get the block and then you have to wait 720 blocks to have that block confirm, and then it goes to this pay to like the certain address, your mining reward address is what it's called, and then you can spend it from your wallet. When we're collateralizing, what the actual miner of the block is doing, they're changing the reward address to the address of the lender. They're getting that block reward in 720 blocks now. But the collateral that they provided is being instantly paid to all the miners. And the difference is that the collateral they provided is going to be a slightly less amount. And that slightly less amount that's being missing is the fee that the collateral provider gets at the end after 720 blocks. Sorry, can you repeat that? Right. Yeah. That's the current idea right now. Right now that's actually not implemented in the testnet. Right now anybody can provide collateral. But the idea is that miners who mine on the pool will get Lithos tokens, and then in order to create a collateral contract that will be used as collateral for any blocks being found, you will have to stake some sort. You'll have to, I don't want to say stake. You'll have to lock a certain amount of Lithos tokens inside of that UTXO, and that sort of ensures that there's sort of a market for collateralizers to get Lithos tokens and for miners to sell those Lithos tokens to those collateralizers. So collateralizers, they get the Lithos tokens, they get gain on their ERG, and then miners, they're selling those Lithos tokens to those collateralizers. I'm not gonna lie, I haven't determined the exact amounts yet. I'm still thinking about sort of the tokenomics of the Lithos token. It hasn't really been my main focus. My main focus has been having like a usable protocol, and then I feel that tokenomics after will be more important. But yeah, it doesn't have to be confirmed, you said? Yeah, theoretically, yes, it does not have to be ERG. However, the lender will be paid in ERG no matter what. Yeah, but yes, theoretically the collateral could be anything that they want. And if the miners choose, for example, to get paid in SIG USD, they could if they wanted to. Yeah. Yeah, no, I definitely I think that's fair, honestly. I initially did not even think about a token, but I felt like I want to incentivize collateralization and incentivize people to join decentralized mining pools because honestly, most miners they want whatever works, right? And they see a stratum on Hero Pool, they're going to go join that. They're not going to join Lithos. So I feel like there should be some sort of incentivization for them as well to be part of a decentralized mining pool. And in that way, we're we're ensuring that more people will join this decentralized mining pool um, because they're getting paid a little bit extra, right? And that's not to mention as well MEV and storage rent, which will be additional rewards for them to join a decentralized mining pool as well. Hmm. Yeah, yeah. Hmm. No, I think it's tough because especially these days, a lot of tokens are useless, in my opinion. There's a lot of things that don't need tokens that have them. So definitely, it's something I've thought about with Lithos as well. Do I need a token? Do I want a token? Is it really necessary? Currently, right now, I feel like a token will be useful in that sense. But right now, the main focus has been the protocol, making sure that works. And then tokenomics will be most likely the last thing I work on. I don't want to prioritize it because while it is important, it's not the main focus of the protocol itself. The main focus of the protocol is decentralizing mining. Yeah. Hmm. Yeah. 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 It is kind of similar to that, I believe. Yeah. Hmm. Yeah, I think it's an interesting idea. And it allows people who aren't mining to gain ERG. And I feel like that's been a big pain point for some people. The Ergo ecosystem. I've heard that mentioned before in the past. I'm not a miner. How do I gain value on my ERG? And now obviously there's a few more ways to do that, but I think having another option for that is useful. Cool. Any other questions? For for mhm. Right. It's mhm. That's actually a really good question. Right now, the idea was that on the HTML UI, you'll be able to see all potential pools that you could join if you want to join a specific pool that has like a certain cause associated with it, or maybe it pays out in a certain way. So that is the general idea. But I think if I can find a way to get it on mining pool stats, that would be so cool. I think it would open it up to a lot more miners, and miners can really see, oh, there's all these decentralized pools. Maybe I can join this one or this one, etc. So I think that's a good idea, definitely. I'm not sure how I would go about adding it, but I could talk to the mining pool stats guy. He's actually, I've talked to him before when I worked at GetBlock, so he's pretty chill about things. So yeah, I'll ask him about it, see if we can get it integrated there. Right. No, yeah, yeah, it's a good idea for sure. I think one thing also is that because we're using NISPs, it's not really easy to see how much hash rate is on the pool itself totally. We can estimate it, but technically, because NISPs are sort of taking only a small amount of data, it's hard to figure out the exact hash rate. So I'd have to figure that problem out because mining pool stats requires that. But no, I think it's a really good idea. I'll definitely think about it. Anybody who wants to be a sequencer, actually, because sequencers are the ones who are taking these NISPs and then submitting them to the actual blockchain to be evaluated. So anybody who wants to be a sequencer can do that. You can, if you're a miner, you can do that. If you want to be a collateralizer and be a sequencer, that's also allowed. Currently, the idea is to have like a small amount of Lithos token to become a sequencer. Um, there may be changes to that in the future, but right now, we want sequencers to be the ones submitting things, because it just makes it a little bit easier in terms of evaluating all of the different NISPs off chain. Uh, yeah, so sequencers would be the ones creating pools and bootstrapping them. I guess actually now I think about it, I suppose miners could do it too. You don't necessarily have to be a sequencer. Now I think about it. I mhm. Yeah, yeah. I guess realistically, because making a pool doesn't necessarily will require you to send too many transactions. Actually, theoretically, anybody could make a pool if they wanted to, as long as they give a certain amount to prevent spam. Oh, yeah, whatever. Yeah, I don't know who even did that. All right, so that's it, guys. Thank you very much.
All right. All right. Hey, everybody. My name is Cannon. Thank you all for allowing a non-dev to talk to you today. This has, I actually think, pretty decent implications or a vector for devs to put their head around. It's getting out from behind the keyboard a bit, but there's a lot of protocol that would need to be developed. So anyway, long and short of it, I talked to this a little bit over the last year, mentioned it to Joe a couple times, and he asked me to give a presentation on it. I think it'll be interesting. And so I did. So here we are. Commercial barter meets permissionless infrastructure. I will try not to read the slides. That'll be the only one. So let's get going. A hidden B2B economy, but we're here for peer-to-peer. Most crypto is looking at speculation, right? Look at yesterday, big crash, people on dexes, sort of playing lotto. Bartering worldwide is, or in North America, is about a 12 to $14 billion market. What we're focusing on is a smaller subset that is um, like non-governmental, uh, big, huge corporate kind of moves. Um, so anyway, they're tax compliant. That's one of the things that people often get confused by. Um, And you don't really need to convince these guys about not using fiat. They use their own barter currency. So what is a barter exchange? It's not eggs for tomatoes. Sorry, Jemai. Um, not getting chickens from the Russians down the street or selling them. It is not skirting tax laws, doing something for cash to try to, get a little bit more juice in your pocket. Um, and it's not government counter trade deals. Now, that is a larger barter thing where, like, a city might give somebody like advertising or something at a big fair and you reciprocate. That's part of the bigger number. It's a formal B2B exchange network. This is probably one of the only few slides I'll read, but they do real accounting and tax reporting. So you actually get a 1099B. So those of you in the US that have been a contractor before, you get a 1099. You usually don't look at the letter, but B is for barter, C is for whatever. There's several of them. There are large networks, 140 million annually. iTex is the biggest. IMS is independent. They have franchises. And then you have regional networks like the local trade partners, which is in my area. They're a couple hours away from me. They're doing about 10 million a year. And we'll talk about them a little bit more specifically. And then Rocky Mountain Barter, I found one that's actually here. I think they're out of Colorado Springs. They do about 500,000 a year. And again, this is not using cash. It's using, you're bartering and then receiving credits in a barter currency. So what about regional currencies? It is not Berkshire's, Ithaca Hours, Petit Monet. I think I showed that to Luca. It's outside of Montreal in sort of a little enclave. They've printed their own currency. It's sweet looking. A lot of those are geographic based, they're time based, and they get a big bump and then they fall apart. And most of them don't scale beyond $1 million. So it's not that they don't fail, but uh, from a dev standpoint or a protocol standpoint, it's hard to create a business around something that doesn't scale beyond $1 million. It's a pretty small fish. Um, these are business to business networks. They have their own ledger systems. We'll get into that just briefly. The network operator actually provides a ton of value. They will mediate, they will help push deals across the table, and their scale. It's 2.5 billion conservatively a year for the last, growing, but it's a big number. Here's an example. Local trade partner, in my area in the Ozarks, in sort of central, south central in the U.S. Alice builds a deck for somebody, gets paid 50,000 or 55,000 in credits. Those credits are LTP credits, so local trade partner currency credits. You get a statement every month from them, like a bank, saying, hey, here's how many credits you have. She gets that full value. It's pretty small up there, but her variable cost is $3,000. Come to find out a couple months later, that year, whatever, she needs to get a couple crowns in her head for teeth. There's a lot of dentists on these things, honestly. And so she pays that dentist 4,500 in credits. That dentist gets the full 4,500. What she has to do in our local trade partner exchange is she has to pay 10% to the local trade partner like organization. So she pays 49.50 out of pocket or using her credits. And so you're sort of thinking, well, that's just a swap, right? Like you're swapping horses, nothing really happened for you there. Well, if her variable cost was 3 grand and she just got $4,500 worth of new teeth in her head, she actually made a 50% ROI. And so we're going to hammer that home a little bit in this. It's pretty common in business. Not a lot of people do it well, but it's variable costing. You can have fixed costs. You always got to pay them. You always got to pay rent. You always got to pay payroll, unless you got guys on a really flexible schedule. You got cars, you got equipment, but what was your actual variable cost? So for her building a deck, she had a little bit of lumber, a little bit of labor, and that's it. Um, so she was able to turn that 3,000 into $4,500 worth of teeth. Do you have a question or yeah? Okay. Yeah, variable. And I use this Alice example sort of throughout, and there's a few others, but I try to carry this one throughout the thing. Um, and so it's idle capacity arbitrage, right? So Dev, perk up your ears. You heard arbitrage. How do I make money on this? Um, so without barter, she has an idle crew and equipment that day that they were building that deck. She didn't get the business. Once you're in these networks and you're established and you've sort of like put your name out there, you start getting business that you wouldn't normally get because people have this sort of fake ROI you can create from, your own value. So basically, the dental work would cost her 4,500 bucks out of pocket. Like we said, with barter, 3,000 variable cost, she makes about 1,500 bucks, the difference between the 3,000 she spent to build that deck for somebody and what she receives in value from the dentist. So sort of think about like Airbnb with an empty room or a hotel with an empty room, right? Like what's that variable cost for them to book you one night? It's not a lot. Or think about your mining rig with excess electricity, right? Or you've paid off the cards, so you're not worried about depreciating those cards into the cost of the coin you're mining. So this is, uh, we talked about it a bit, about 2.5 billion in the retail barter exchange sector. That's mainly, I'm looking at North America. There are definitely some in Europe as well and Asia. About 400 across the globe. This is again only about a 20% of the subset, and this is really the only one that I would think anyone would focus on. Geographic industry, we'll get to that. What makes an ideal business for bartering? High fixed costs or no fixed costs, low marginal costs, perishable capacity. So think of time constraint, think of your hotel rooms, restaurant, your tables. You can only have people eat that night and then it's gone till the next day. Having excess capacity and being an independent owner. So there's some ratios I put on here and whatnot. People can look at the slides later. Um, a few of the things, this will be a little hard to see maybe. Well, no, it shows up pretty good. Really your best options, I sort of went through these and sort of scored them out. Your best ones are hotels, advertising media. I'd put programming in there as well with advertising media. Pet boarding, because if anyone's boarded their dog, right, like no one's doing anything. They're checking them like once a day or twice a day. Like, I mean, they're already there checking other dogs. Um, Chiropractic, a lot of them they're already doing a lot of cash business. So this is another way for them to sort of enhance it. Legal services, usually you have to be solo. It's hard to do it as part of a bigger like legal practice because billable hours and all that kind of crap. Accounting, if you're tax focused. And then dental's a little harder. If you're an independent standalone, that's great. Like my cousin, he has his own, dental practice for the last like 25, 30 years. If you're newer coming out of dental school, typically you start working for somebody or a corporation that owns like multiple dental offices. It's harder to break into it because of the debt coming out of school and the equipment cost. Same thing for veterinarians if they're independent. That's a good one. So real world economics, hotel, you have 300 hotel rooms here in downtown Colorado Springs. Uh, Federal government shut down, so you're at least a third behind. If you can charge $100 a night on those rooms, you'd make 15,000 bucks. Actual cost is some cleaning supplies, maybe have to bring in one extra person to clean them, two extra people. And so you can start looking at what your effective return is. Again, that's another example of the sort of variable cost versus fixed costs. They already had to pay electricity for the day, water bill, everything else to maintain the hotel property. But your variable cost in the hotel is truly only your cleaning staff and the supplies they use to clean the room. Uh, Deep dive. So the network operators, the people who run these barter exchanges, um, they are a trusted intermediary. So thinking maybe like Rosen, even like in between a transaction, like you're submitting it, sort of you can see it. Uh, they're a little bizarre. They're all over the map. Some charge a sign up fee. The one I'm in is free, like no fees other than that 10%. Some charge you a monthly fee in cash and currency. Some charge anywhere from 6 to 15% on your spending. Some charge you when you receive as well. So I mean, it's like they're all over the map on where they're taking your money or taking the credits. Um, this one doesn't really matter. Yeah. So they have a dollar peg mechanism in theory. And I say in theory, iTex, they were a public company. Again, they're the biggest one. They had a SEC fraud case right around the dot-com bubble where they were inflating their revenues and sales to get everyone on there. And there was basically a flash crash. People went out of business during the dot-coms, and there weren't enough credits to go around. Like they couldn't make it work. So they actually had a SEC fine. They're no longer public. They sort of took it private after that. But it sort of goes to show you, like, danger of opacity, like we talked about several times today already. Um, and fragmentation. So this sort of made me think of Rosen a bit, right? Talking about your stranded value. Alice is in the Ozarks. She has 50,000 worth of credits built up over several years. She semi-retires and just shuts down the business, which not everyone always sells their business. It may just be her and one of the two other people, and she just shuts it down. She moves to New York, gets an itch, starts up a business there. She can't really use any of those credits because you can't take a trade currency dollar in the Ozarks. No one in New York City gives a shit, right? Like they're not gonna give you any money for it. So you get stranded. You can They will facilitate a little bit at this point, but that's a huge missing layer. So these guys do a great job vetting members, bringing them on board, tax reporting, dealing with issues between vendors on the exchange. They're not interoperable across the different exchanges. There is no transparent reserves, no capital efficiency. They won't lend you money. You can't borrow credits. You can't lend your credits. And there's no neutral settlement layer across the different exchanges. No, no. which is why I think this is a very good opportunity for the right people. So there are two actual federated, if you want to call them bridges, Barter Association National Currency. NATE is the National Association of Trade Exchanges. Uh, you as a vendor on an exchange cannot use it. Your local exchange that you're part of has to pay a fee. Then they take some cut of your money going across to a new exchange. They have to approve everything. There's a lot of horse swapping and a lot of phone calls to get this thing done. That one, they have to approve your exchange. Only 40 exchanges are in there. There's over 200 exchanges across the US. So it's not that big. They're basically the bigger ones working together, keeping the small guys out. And then you have universal currency, which is bigger, the international, uh, shoot, I'm not going to remember, something in trading association, retail trading association, I think. Uh, they have 100 of the exchanges globally. They're a little bit larger. They charge a quarter point on every dollar that flows through them across these different networks, which isn't too bad. Uh, to be a member of that trade organization is not hard. It's not like it's more of an open option. But there's several hundred that basically aren't connected in any way, shape, or form. And they might be, but when I talked to my guys and said, hey, I'm coming out to Colorado as an example, what if I had credits and I wanted to use them at a hotel here, Airbnb, restaurant, whatever, book a restaurant for everybody, with some free credits I had. And he was like, well, I'd have to make a lot of calls. Like it's always like, yeah, it can be done, but it's not probably doable or very possible. Ergo's value proposition or a project protocol on Ergo. Economics, 1 million of volume, cost 1% probably on the other exchanges on Ergo. It's a couple $100. Access, you can make it permissionless. You could also make it permissioned, just to vet the exchanges that are coming on board. Transparency would be there, privacy, we can use Sigma protocols, zero knowledge proofs, etc. And we'll get into that a little bit. And you allow the networks to do what they do, what they're good at, right? They're good at being the local person holding everybody's hand and shaking hands and kissing babies locally, and we can handle the actual settlement, moving things around, and being that kind of layer. Again, addressable market, I'm hitting this again just so that you guys see it, 2.5 billion. And that's globally, but probably 80% of that's North America. Current exchange volume, it's not really, and I mean inter exchange volume, it's not really published anywhere, but in total. So it's probably about 20 million. So maybe 20, 30 million out of 2.5 billion is moving across these exchanges. I'd say if you only got 10% of adoption, you're looking at a quarter billion moving annually on Ergo. And again, you don't have a lot of gatekeepers to overcome, and it's not about replacing these exchanges. I've sort of gone down that route. In real world assets, total volume on Ergo, I have no clue. I'm sorry. Like, I mean, maybe 500,000 a day before the price is lower now. So maybe like 400,000. Yeah, probably. Yeah. And it's not about replacing these exchanges, right? It's about connecting them. They're good at what they do. They are a value add for their members. It's not like they're doing a shitty job necessarily. It's that they don't really have the tooling to do what would even make it a uh, better tool for their members. Uh, Programmability, privacy, blockchain in general, efficiency, sustainability, permissionless. You have security. So multi-party settlement, escrow. I mean, Luca, MG Pi, and NZ. Who was the other? Yeah, helped us with Sigma Lock. We'll show you guys that a little bit later on today. But I mean, that's a pretty sweet little escrow or conditional logic that we have be applicable here. Something similar to that would be applicable here. Um, why not other chains? And you'd see this if anybody else gave this from Polkadot or Cardano or anything else. But Bitcoin, limited programmability, Ethereum, high fees. How are you going to do small transactions? Unless you go to layer 2, and then you got other issues there possibly. Pre-mine foundation control. It's not really as neutral as you want it to be. I think earlier we were talking about privacy and ZK proofs on some of those networks, and are they really private if that's what they're pushing you towards? Permissioned chains, I'd sort of put like proof of stake pretty much right there. You still have gatekeepers, network politics, and then most other L1s. I mean, it's centralized, expensive, or their tokenomics aren't really sustainable. Um, Ergo, we know we're expressive on top of UTXO. Perfect fit for if you're trying to move 1,000 credits from this network to that network. And boxes can reference other boxes. I mean, I'm talking to devs. You guys know this stuff. It's not really, I'm giving you guys a whole lot of info here. Sigma protocols. I've been noodling around with the opportunity of if you brought on one of these exchanges, say the local trade partners in the Ozarks, their software has API access. You could prove credit history, you could prove collateral, you could prove borrowing requirements for the actual individual vendors, right? Some of that data can be fed in to a protocol. And we'll get to that in a little bit. I mean, there's some cool things you can do. Storage rent, it sounds hokey, but I think demurrage is pretty cool. Some of the more successful local currencies have had a attrition, like it expires at some point in time, so you could just tell the exchange that's part of the deal. This stuff's only going to be there for 4 years, use it or lose it, and that should actually be a motivating thing for the exchange because the vendors will then use their exchange more, they make more fees, et cetera, et cetera. Transaction finality, 2 minutes for block. It's a day for, full lockdown confirmation, but 2 minutes isn't a big deal. Sub blocks is coming up, so it wouldn't even be a deal. Low fees, developer tools. We have some of the existing frameworks or concepts that could be applied to this. Current isolated islands. So you got the iTex network, the one that committed fraud 25 years ago, the one with mine in the Ozarks, and the one here in Rocky Mountain. If they're going to connect, they got to make phone calls, faxes, emails. I mean, just old school crap, right, to get it done. I don't even know. They might even be using mail still. There's no liquidity moving across. And again, it's the whole stranded value, dead capital. Say you build up a lot of business, but you haven't been able to spend it yet. You might have $30,000 worth of credits. Like Alice, she has built a bunch of decks for people. Now she needs to wait till the winter when she can actually do the maintenance on her equipment, buy new equipment, whatever. Future shared infrastructure. ITEX has 5,000 members. The Ozarks, they have 500. The one here locally has 100. So now you've combined this and made it, 5,600 members with a settlement layer that works and sort of feeds what they need. Yeah, the real innovation is not technical. It is, don't get me wrong, devs, but it's recognizing that the network is the value creator, not us. They're not just rent-seeking shitty middlemen like Coinbase. The blockchain is an infrastructure layer, right? It can be their account ledger that's open, transparent. Simple contracts are better than a complex bridge. Not looking to build a replacement or some kind of super complex bridge. it would all be settled on Ergo. You wouldn't have to like move across to Ethereum and different stuff. We could because Rosen exists, but there would really be no need to do that. One of the discussions today about AVL trees and things like that. I mean, you can do some pretty neat stuff with their ledgers and just like keep augmenting them. I mean, just on chain. I mean, have a easily viewable what's happening. Um, so yeah, potential core innovations, cross network settlement bridge for them, it would be a big thing. So let's talk about Alice again. She needs some specialty wood for this deck. She's building something for one of my clients. It has like a $20 million house. It looks like an art museum. And he has really nice teak wood. And he wants it aspen. He wants it to be, you know, like he wants to be able to tell all his friends about it. Uh, she could call Bob and he's like, hey, I'm in a barter network. She asks him, and then, you know, how do we make that happen? And Bob's like, well, hell, I'm coming to the Ozarks. I'm going to Crystal Bridges. It's the nicest art museum in the US outside of New York or DC, and has the largest, uh, just for a little plug, the most American art in the world at one location. In fact, that's what it's dedicated to. And it has a Frank Lloyd Wright house that they deconstructed, reconstructed there. It's pretty sweet. So he's going to go there. He's already planning on it. So he's like, sweet. You know, yeah, I'll give you the wood, you give me the credits, but like, how do we make that happen, right? Like, different networks, they're not operable. You know, that's sort of where we come in, or innovation would come in. Uh, Same kind of things that we've talked about with Sigma Lock or some of the other uh, staking locking protocols. You know, if you don't accept, it's auto refunded. If an oracle doesn't attest to it, etc. I mean, there's, you know, different things to fail safe this. Um, so Alice would initiate the request. It goes to Bob. I mean, this looks like any, you know, cross network swap, nothing fancy to us, but to them, it would allow them to actually do a business deal and get what they wanted. Um, so, yeah, it's pretty neat to me as more of a business guy, not a dev guy. Lending and borrowing pools, think duck pools, think something similar. Some of the staking you guys were talking about, that sort of comes into this as well. Um, right now, I have not found a barter exchange out of the 2.5 billion of annual volume. I haven't found one that allows people to lend their barter credits to others. Might happen, I don't know, but I haven't found it yet. So I think that's a pretty, you know, neat, easy thing for Ergo to be able to accomplish for these people, even if it's within your own network. I'm not talking about using Ozark credits to get Rocky Mountain. I'm just talking about, you know, I got a bunch of credits I don't need right now. Let someone else get them for cheap or borrow them. There's a scenario here. It's not really that important, really, but it's Alice is seasonal, right? So she builds up a lot of credits in the spring, summer, fall. And then in the winter, she needs to spend credits because she's going to buy a new vehicle or some new equipment, whatnot. So in the summer, she has 40,000 idle credits just sitting there till the winter when she can actually upgrade her equipment. And it's sort of when she has time to work on the new equipment, get it all set up, ready for the next year. With lending pools, she can put that out, let other people borrow it. Um, you can do something, I mean, similar to duck pools, just say, hey, it's a 3% or 4% base, and then it's based on, you know, utilization, right? And just put a utilization curve on it, nothing exotic. These are regular business people that have a bank account. 3% is nice, right? Like, I mean, there's a way for the protocol to capture value here, right? Like, because they're allowing that to occur. Uh, and then in the winter, she needs to get 30 or 25, $35,000 worth of stuff. Then she can either borrow and just have like a 2 or 3% spread against her borrowing cost versus her lending cost, or cash in her credits. I mean, she may want a bigger truck next year, so she's going to keep the credits and just pay that marginal spread. There's a lot of ways to look at it. Uh, you can do some on-chain credit scoring. It seems like it's possible. These exchanges, the one in Central Arkansas where I'm at is it's on AS400 in grain bar paper. Like, I mean, you ain't getting nothing out of them. The one up in the Ozarks, there is one platform. He continues to buy out other platforms. That is the software platform that powers these networks. He's good at what he does. Um, there's API access, things like that. So they have all the transaction volumes. They know reliability of vendors, grading of the vendors. Yeah, one guy, he's out in Boston. MG Pi may need to go meet with him. And but yeah, I mean, you could create a credit scoring, right? Like off of the data that the network already has. And think about if you're Alice trying to get wood from Bob and maybe you didn't have enough credits, you could say, hey, let me give you an IOU, right? Like, and he would accept your network IOU because he sees you have great credit score and you're not welching on your bets, right? Like you're a real person. Um, so yeah, a little bit about like the interest rate discovery. This isn't new to anybody who's used duck pools or a lot of the other lending protocols that exist now, but just a utilization, based. For example, my line of credit at my bank is 7.75%. So I mean, 8%, hell, I'd borrow all day on that. Like that wouldn't bother me at all if I could get credits and I knew I was going to earn some more that year and pay them off. That's no big deal. 14%, 20% might be a little iffy, but what it does is as those rates get higher, people add more to the pool, like you guys have seen with duck pools, and then it starts pushing the interest rate down until borrowers go back up. You just hit that equilibrium. Decentralized lending pool mechanics. You guys know the drill if you've used duck pools. But think if you're the hotel, I mean, you can just start making extra money on this, right? If you're an independent hotel or independent franchise is allowed to do it. Say you're the landscape guy that's starting up your own company and you don't have all the equipment you need, you can go out and now borrow money in the network and then go to the Toro dealer that's in the network and get your equipment. And again, the local barter exchange is happy about this because you just created more volume for them to pocket 10% or 15% or whatever it is. And they have more members. Um, Provable reserves, like a centralized exchange, you don't know. And some of these have gone under. So you could build up credits in one of these, and again, you don't get paid cash, right? So if I do work under this exchange, I get no cash. It's all in these trade credits. If this trade organization goes out of business, I effectively just did work for worse than free. I paid materials into it too, right? Like not just time and effort, like not just the variable cost, but everything's gone. Um, so you could do, again, provable reserves, that everything balances out in these things. Um, you'd have a dashboard, pretty simple. I mean, in theory, right? Some UX issues there, but there's a fraud case. It's impossible to inflate reserves if it's actually there on chain. Um, and this would help people if they want to join the network or trade with the network. You may not want to send your credits to the Rocky Mountain Network because it looks a little dodgy or they're not that well collateralized, right? There's more on one side than the other just because of the imbalance that's occurring. Oracle problems, like always, right? Reputation, time delay, etc. Scalability, user experience. I mean, all these things I think are pretty simple to do, but with the right tools and the right people. Um, Regulatory. Um, I haven't looked into this all the way. I don't think that they already do this, right? So like my exchange in the Ozarks will send money to another one. I don't think that there's a money transmission license to deal with or anything like that, or they already have that sorted out themselves. Um, I don't think it really adds a whole lot of tax reporting complexity. The only thing it would add is 1099 INT for interest earned on the pooled lending. Yeah, and they're already getting a 1099B. So I mean, you're just giving them one more data point to give to these people to show that you earned interest on your credits. Um, yeah, the bigger issue is adoption, right? It's always a chicken and egg thing. Um, and so I think it would be starting with a couple smaller ones that are accessible and progressive, and then going from there. Yes. Uh, Well, right. Yeah, I'm not. Yeah, so the question was about algorithmic stable coins and if it's pegging to that. I'm not saying peg it to the now algorithmic stable coin. Yeah, if you had local trade partner credits or dollars and then you had one from New York or one from, wherever, it's still in that currency. You're not commingling those pools per se, right? So like you would set up a lending pool for each of those networks. And then you would give them the ability to borrow in that network because you want to buy aspen wood from the guy right down the street or from Joe and tell him to go log a couple off his property. I mean, that's sort of the way it would go. Uh, nobody, nobody. Banks, yeah, it's banks, yeah, yeah. So that's why everyone should want to do it. Um, because you can, as the vendor, you can become your own bank or at least partially your own bank, right? So like you can now pay. I had this concept in grad school, so I used to audit a couple companies that were small, like they did fishing lures, and then another one that was in Walmart, right? And they blew up, and Walmart blows you up to a certain size, like 20, 30 million in sales, and you're like, woo! And then you have to go out and get a $20 million loan to sustain that. And then once they know you got that loan, 3 months later, they come to you and go, I think I'm gonna have to pay about 50 cents on the dollar what I used to pay you. And like they just sort of get you squeezed in. And then on top of that, they pay you at 120 days. So it's like they're screwing you every different way. But now you can. I had a concept in grad school that if Walmart actually became a lender to their vendors, they'd make more money than what they're doing now by squeezing everyone for 120-day terms. Uh, no, it would work. Like economically, it should work. So I think this could actually create a bigger alternative economy when the business can become partially their own line of credit, right? Like you have free credits or you've earned credits that now you can lend out. So anyway, um, struggling business, most eager to borrow. That gets back to the vetting on the front end from the network and the transaction history they already have on these people and sort of bringing that on chain so that uh, I talked about the equilibrium, but you can also put penalties, right? Like give them a credit score. And if your credit score is bad or you're new, you have a bad credit score, right? When you're 17, 18, 19, you don't have a good credit score because you haven't built up credit, right? In theory. And so they could have to pay an extra 5 or 10% or whatever, right, to get the credits. So yeah, that's sort of the presentation. So yeah, they're already operating peer to peer. So yeah, any other questions? I have a bunch of just random stuff back here. Right. Well, no, yeah, so the question is, do you need a credit score? Yeah, right. Well, so uh, what I looked at was collateralized, right? Because we're familiar with duck pools. If it's more a traditional like bank-based, on credit scores, then you could hybrid it, right? And they might even be able to onboard more businesses to the network because now you can borrow at a better rate to get equipment from the Toro dealer or the Ford truck dealer or whatever, right? Like it sort of makes that network even more powerful, in my opinion. Um, but yeah, that's the whole thing. Go ahead, Chris. Oh, hold on. Say it again. Right. So yeah, the question is like, does tokenizing the credits like add a new tax layer for the vendor like Alice or Bob that we were talking about? Um, so I would look at it more like one, I could be wrong, and I'm wrong every day very often, but uh, I think if you're providing this service, right? If Alice builds up 40,000 in credits, she's getting like say she gets paid 40,000 that year for building decks. She's getting a 1099B from the local trade partners that you file that 1099B on your tax return, business tax return, or personal, just however you're set up as a corporation. That flows through as 40,000 of income because you have your normal expenses you're paying out in fiat, right? So like it's already there. It's just like a receipt. And so the only thing I'm looking at is the interest you would be earning would then generate a 1099 INT, right? Like you get from a bank showing we paid you 0.02% interest this year on your cash. Thanks for parking all your money with Bank of America. So it would be that kind of thing. I'm not looking at it where Alice necessarily has, and this is going to sound funny. I'm not looking at it per se where Alice has like an Ergo wallet and she has like these local trade partner credit tokens in her wallet. We're the settlement layer for it. I'm not sure if you wouldn't just reskin Nautilus to where that's all they see is like their one thing. Like, I mean, just make it its own silo or even maybe do a side chain for all this. I don't know per se. Well, and you would also send out a what's the one? We would also need to send out, or we would provide the information to the local exchange network so that they could give you the 1099 and maybe 1098 like on like your home loan that shows the interest you paid, but it'd be like a interest expense, right? Like they need to be able to put that on their tax return like, hey, I borrowed money and I paid $1,000, right? Like they need to be able to put that on their return. Yeah, this one. Yeah, where like she profits. So yeah, so it's sort of it's a good example and it's not, right? Because you're trying to show business and I showed her getting like teeth. Uh let's say she bought I don't know, a auger attachment for a skid steer, so she can put in deck poles, right? Like I mean, so she can drive them. Um yeah. Well, and the auger bit, I mean it's several grand, but it depends on if you got it new or used. But so that 5 grand, she gets something that is reported to the IRS, and then she reports to the IRS on her business tax form that she made $5,000 in income. It's just like normal income. The expense would then be she keeps record, like she's getting an invoice. You're still getting an invoice showing payment, right? It's just that it got settled in this non-fiat currency. And then extra 10% that she pays the network, they report something to her showing that she paid that fee as well. So that's also a business deduction. So, yeah. No, she built a deck, right? So she went out and built a deck for someone, got $5,000. She gives them an invoice. They pay her 5,000 in credits. They have the invoice to show that they paid that expense. Right. Yes. Right. Right. Well, uh, so the question is if banks are already getting affected by it, does it how do I say this clearly? Are they going to take notice and, is anything we're doing affecting a bank? Yeah, yeah, yeah. If this thing grows because of this, like because it becomes more attractive to businesses, small, medium businesses to do this, does it affect banks? Possibly. I don't know. I mean, my family friend that owns it, I mean, I don't know, it's like a 50 branch bank. He doesn't give a shit about $2 billion. I mean, like it's not all in his network. Like it's spread across so many banks. They don't know they're not getting it right now. I mean, honestly, 2 billion is nothing to banking system. Like it's nothing. And yeah, and you said, so what's holding back this concept? A lot of people, I think Joe may have said it, someone else may have said it as well. People are sort of inherently lazy, right? This takes a little bit extra hustle, right? One, it takes you, if you're a barter member, to say, hey, can I pay you in barter bucks, right? And most people feel uncomfortable trying to do something like that or hustle or, whatever. Um, it's something else to have to deal with. Uh, and yeah, so if I do a project and make like 8, 10 grand in some guy's backyard doing this project for him, how long am I going to sit on that 10 grand? Like I better have very low fixed costs and very low variable costs because I might be sitting on that 10 grand for a while before I can use it all. And that's what I think to me, it's a fungibility, like you said. And I think it's also a network effect issue. I mean, none of them have scale, right? So, I mean, there's always that network effect. They've done really good. So like Colorado Springs, you guys have been around here a bit, but it's like 750 like MSA, maybe a million. Like it's a good sized population. Northwest Arkansas, fastest growing MSA in the country for multiple years now in a row. Yeah. It's about 750K now. When I was, like 20, 30 years ago, there's maybe like 250 people. Yeah, 250,000 people. So it's if they have about 750,000 in their MSA, Metropolitan Statistic Association or area, metropolitan, yeah, area, um, and they're doing 10 million a year. Those guys are hustling, but they're hustling because you saw they're making 10%, right? So that's like three people. One of them's a secretary, one of them's the owner, and one of them's this business dev guy, splitting $1 million a year. That's pretty good coin, right? And I'm not saying replace those guys. They should be getting paid that if they're hustling that hard. The guys in Rocky Mountain are doing 500,000 a year. Could. I mean, I think the lending pools is a big thing. I think there's the cross network thing is pretty huge. Making that available, but that's a chicken egg thing. I think the in network lending I think is the biggest, and I believe uh, why it's also a hurdle is the software that exists could easily do this as well, right? This isn't hard, it's a ledger. I mean, not being nasty to blockchain or Ergo, but it's a ledger, right? This software is already keeping a ledger, doing their 1099s. It's not, it's not, uh, it's not clear and transparent, right? So like, why would I lend my bucks out of my account on this network when I can't see where they're going or anything else, right? So I mean, I think that's where blockchain trumps the federated or, closed system. Um, yeah, right, right. How to do a right. Y- y- I have and I haven't, right? Like this has sort of been in the back of my head for a while, and I sort of spit it out the last couple of days. What are you guys raising your hands here in the front row? No? Okay. Yeah. We'll pay in Faku. Um, that'll get every dev running. Yeah, so the question from Chris was like, what would it take to attract a dev to do this? I honestly, I don't know. I don't truly know how complex this is. At the end of the day, I think it is more, and that's why I said it's a non-dev dev thing. I think it's more getting the first couple exchanges on board with giving you the data, right? Giving you the API access to the data or whatever the output from their system to get that data. And then what can you do with it? With the lending pools, I think one, two, three, four, five, six, seven. I think there's seven devs in here. That whole side of the room, actually. Um, I think any of them could take duck pools and modify it for this. I mean, or find a way to modify it for this. Um, and so, I mean, if you started with that as a proof of concept, right? Just the lending pool. So, I mean, I think, again, to Joe's earlier point today of we strive for open protocols for a reason. I think this is a good bolt-on reason. I mean, it sort of segued into what I was talking about, but I mean, I think anybody in here that I'm looking at that's devs on this side, they're all way more talented than anything I would come up with or even want to teach someone, I mean, they can modify that stuff. It's there. I mean, some of the back end maybe isn't, or, some of the front end stuff we'd have to develop, but I mean, some of it's sort of there in a way. Right. Oh, sure. Right. Right. Yeah, so that's a good question. So what piece of the pie is for the dev? The existing software that I said, like several of the more modern exchanges are ones that have decent websites and whatnot. I mean, it's sort of like if you want to think of Zoho or like Salesforce, like CRM, like it's a CRM basically with this bolted onto it. But a guy's built it from scratch. Like it's not. I've sort of looked at it enough to see that at least I believe it's not like a existing CRM package. It's what he's built from scratch. Um, I don't know what he charges for that software. I've tried to find out. It's obviously not published. There's not a lot of customers for it, right? So if it's one dev and he's charging 5 grand a year to, I don't know, 40, 50 customers, I mean, that's a pretty good nut. And he can do other stuff because now he just has a spinning top, right? Without a whole lot of, moving parts going forward. So what this would earn or yield, I mean, to me, it's going to have to be built at cost to figure out how to monetize it. Like, I don't know if it's earning off the lending pool. I don't know if it's a fee to the networks. They're already paying a fee to this guy. Does he try to replicate it? I mean, there's a couple moving parts. So I don't have a good answer for that because I really haven't taken that step in my head because I was still just, noodling around with the research. Yeah, Luke. Mhm. Mhm. Yeah, yeah, so the question is, can you chicken and egg, and do you try to replicate the software for one and get others to join, for interoperability across the networks? I really don't think so. I think it's a can of worms. I mean, right now it's a one guy show, owns somebody built a new one out of Detroit like a couple years ago. He bought them out. I mean, just here's your money. Let's combo it up, right? Like, I don't want competition. It's an oligopoly or a complete monopoly. Yeah, maybe. I mean, there's a lot of ways to skin it, but yeah, no, this was just more just to get people thinking about. I mean, to me, the biggest thing is it is a group that's already organized, already licensed. They're not doing anything shady, and they're not using fiat to the tune of 2.5 billion a year. Is it a sales problem, dev problem? I think for them scaling, it's always going to be a network effect problem. So, and I think yeah, I'm done, man.
It's a super interesting thing because it's like proof of work itself is most profitable when you have excess capacity, whether of energy or
Yep.
of computational power, right? And so networks like this potentially allow people to redirect excess capacity in whatever skill set they have and in essence tokenize it, right?
Yeah, I
Like
mean,
they
in a
turn it
way.
into credit. Now, there's always like the human element where it's like, okay, if I'm a restaurant and my excess capacity is my old shit, is it lower quality, right? And then it's like, okay, how do you create the right enforcement mechanisms? And
Yeah.
some systems I would say probably are a little bit aggressive in terms of like maybe they have credit limits in terms of how much you can spend or where or fees or whatever. But we do see a lot of the quote unquote gig economy that is basically people trying to take excess capacity and turn it into credit. So it's a super interesting idea, in terms of how to coordinate. Like on the organic side, I have no idea. I'm the wrong person. But as a net idea, it's quite fascinating.
Yeah. Yeah, and the only thing I would add to that is it is that excess capacity and the gig economy is growing. So, I mean, I would say that was uh, a lot of the gig economy stuff that I see, and you guys could tell me I'm wrong, but a lot of it is that low variable cost or no fixed cost. So it's like your only variable cost is maybe a little bit of money and your labor. So if you can monetize that, I mean, he was telling me the other day, the guy that, I interface with in ours that's in the Ozarks, he was like, oh, one of my best clients is a independent hotel in Branson, which I mean, they bring in just slews of tourists all year long. He's like, dude, he kills it. Like, I mean, he will absolutely, like, he's calling me all the time, hey, can you take credits from, some other network somewhere else to do it because someone wants to come with their family or extended family and, wants 10 rooms for a week. Well, shit, for him, 10 rooms for a week, he didn't even have to bring in one extra employee. So yeah, he wants those credits because then he can take that and go buy supplies and everything else with it. And he got it for free. I mean, it's real, it's my initial inclination is always just take out Goliath, right? Like just go topple him. But I think this one is more the Trojan horse. I mean, you got to get in first and then figure out there's enough CRM stuff out there that any good dev on this side could skin it and rebuild this thing, I think, in like a week. Like the software or this side. Are there devs over here? I don't know. Oh, we got AI devs. Sorry, yeah. And so yeah, I mean my initial thing is always to toss Goliath on the ground, but it's I think this one's more the Trojan horse. And then figuring out how to do it from there. And then you could, in theory, once you got good enough at this, one of the things with the lending pools that would be, I don't think a hard step, but it does have to be under Sigma protocols, right? Like Alice doesn't want people to know that it's her 30,000 that she's putting on that lending pool. So I mean, like, but I think that's relatively easily doable, but it's not. It's steps that can be done to do that. And then down the road, yeah, once you understand the environment, yeah, you build your own and open it up to any small gig worker, right? And it's like everyone's on one network. You don't need a bunch of them. And you do need them for the deck builders and the dentists and stuff like that because they're a high touch and a high, like, I mean, you gotta massage that person and kiss those babies, right? But for gig workers that want to just monetize their value and see this as a viable way to do it beyond fiat, yeah. I mean, there's some cool stuff you could do down the road. But it's understanding the ecosystem. I don't understand it well enough yet. So anyway, thank you guys. I forgot the Schumacher Institute, Social Trade Organization. Those are two great websites to look at to understand peer-to-peer money and business-to-business stuff. I have an e-book that, I mean, it's free. You can get it yourself, but I can send anybody a copy. It's called Boosting Your Economy by Making Money Virtuous. And it goes through like local currencies and sort of the evolution of them over time and goes into the Sardis currency and some of the bigger ones over time that have been around. Um, that Friedman's Bank book that I talked about is pretty fascinating, just to understand opacity and lending, and it led to a lot of the banking rules that exist in the U.S. now. Because yeah, the Friedman's Bank, yeah, it's called Savings and Trust: The Rise and Fall of the Friedman's Bank. Yeah, yeah, and yeah, they got screwed again. And Small is Beautiful, Economics as if People Mattered. It's a 50-something-year-old book written by the Schumacher guy. I think I got this for $5 on Amazon. Um, he wrote it of the excess going in from the 60s into the early 70s when then we had the oil embargo and crisis, and the first couple chapters he's talking about energy. Like we treat it like a resource that's always going to be there and like you can buy it, right? Because you can extract it from the ground, but it's not something that's always there. So, I mean, his point was there should have been a yield curve on the extraction costs coming out to help society develop solar and wind and whatnot. It's an interesting book, but it's again, it's 50 years old, but it's sort of the same. So far, the first couple, two or three chapters are like ringing true to today in some of the access we got now. So, anyway, I appreciate it, guys. Thank you.
Cool, cool. Hey, welcome everybody. Just going to be going over to why mine Ergo, a guide to profitability, sustainability. Probably, a lot of this stuff, probably very familiar with, but we're just going to go through it at a high level, as well as talk about Sigmanauts mining pool. Cool. And so what we're going to cover today is understanding Ergo, why it matters, the basics of mining, the auto-Lycos algorithm, the technical setup, so setting up the rig, the design of the rig, heat and power, as well as the economics, so costs, breaking even, various analysis, emission schedule impacts, and then as well as the Sigmanauts mining pool. So who is this for? We have whoever's new to crypto, experienced miners, maybe post ETH merge. I think generally if you're interested in crypto, it's probably worth looking into proof of work and then at a minimum, maybe potentially even mining it. And so what is Ergo, as I'm sure most people know, but in case you don't, it's a truly fair blockchain launched in 2019, no pre-mine, no ICO, no VC funding. We have built by experts, so former Chainlink and Cardano developers. We have the max supply around 97.7 million, strictly capped. Mission is decentralized finance to accessible to everyone, and then philosophy is fair launch, community driven, and proof of work secured. Uh, so Ergo is a blockchain done right by the people for the people. And so what is mining? So we got the basics. So mining is securing the blockchain network. You provide computational power, hash rate, and the network rewards you with ERG tokens. Think of it as getting paid to run a security for a digital bank. Your GPU solves complex mathematical puzzles. The more puzzles you solve, the more you earn. Without miners, the blockchain can't function. So, right, we got to secure the transactions, validate the transactions, secure the network rather. And so you're not just earning rewards, you're supporting a revolutionary financial system that is Ergo. And so what makes this so special? So it's ASIC resistant, memory hard proof of work. It's very GPU friendly. It's very cool. And so a lot of those factors for me, at least, as to why mine Ergo make it a lot easier on the cards. I know ASICs companies aren't necessarily going to come into Ergo, sort of rug us. So no ASICs. Like to say, right, maybe potentially true decentralization because essentially anybody can go off and buy a GPU. Anybody generally has a probably hard drive, not hard drive, some sort of desktop computer, potentially with the GPU, maybe a gaming computer. So it's more accessible than potentially mining Bitcoin. And so a critical factor here is the emission schedule. So I believe when I first started mining, it was probably about, I think 75 or 60 erg was the emission. And so now we're all the way down to 12, I believe. The block time is still static 2 seconds. Going to be changing here soon, I believe. And then our reduction schedule is going to be next. Every 3 quarters, it reduces by 3. So 9 to 6 to 3 should be interesting as things sort of move in that direction. So decreasing supply is going to enable scarcity. And so as miners start to mine more and more of this asset, there'll be less and less from a daily perspective being emitted into the ecosystem. And so understanding mining costs, we have your initial investment, but then you have operating costs. And so your initial investment, right, is going to be your GPUs, your motherboards, your CPUs, your power supply, the frame, everything that you need for the complete compute unit. And then your operating costs, right, are going to be something to the effect of your electricity, which is going to be your biggest operating cost, your internet connection, cooling. I think in ventilation is definitely underexplored here, at least from my experience when I first started mining. Maintenance, and then of course pool fees, which generally is around 1% depending upon which mining pools you go to. So yeah, as we say here, the key insight, electricity rate is the key determining factor for profitability. A secondary, I suppose, might be price itself, right? Because if the price is like, if we're at like 100 ergs and that's going to be a little bit different, but of course the difficulty is going to change. So what you need to know about mining, right, is your hash rate. So how fast your GPU mines, that's going to be relative to how much erg you actually earn. Your electricity rate, the network difficulty, so how hard it is to find these specific blocks. GPU power draw, so how much electricity you're actually going to be physically using. And there's differences whether you measure it from the actual device or is it from the software. Obviously you want to measure it from the device, so then that's the most sound measurement. Then of course, current erg price and then the block reward. And again, the block reward is going to change every 3 months or so. And so here is your calculating cost to mine 1 erg. And so why do you want to even calculate the cost to mine 1 erg? So the idea here is, say it costs $1.50 to mine erg, and the current cost is, I think, like 70 cents or even 60 cents. You are at a loss. But now if that cost to erg is say $1, but erg is $2, well then now you're making 50% more. And so this is what this formula is going to be calculating. And I think as miners, we need to sort of look at it as like a business perspective and potentially even at a minimum pay off your electricity costs. But I think additionally, miners are also looking at a speculative bet. So, hey, maybe one day erg is going to go up to this, mythical price. And if that's the case, then sell everything and go down and move to the islands or something, right? Whatever other people's dreams are. And so here it is. So it's your hash rate, multiplied by, divided by the network hash, multiplied by the block reward, and then the blocks per day. So that's how much actual erg you're going to be getting. And then your daily electrical cost. And then once we have those two specific numbers, right? So your daily electrical cost and then the over the daily ergs mined. And so for example, we have here 150 mega hash consuming 150 watts. I think in this example, right, we're just using kind of nice numbers. I think 150 watts at 150 mega hash is quite high. So with and I haven't validated these numbers, so but in any case, network hash rate 50 terahash. The electricity is 12 kilowatts per hour. Block reward is 12, and so your daily erg is about a quarter of an erg. Your daily cost is going to be 43 cents. So then your cost per erg is going to be $1.67. So you're instantly paying more for your erg. And so that is that calculation. But again, this could be more of the speculative play. And so, hey, maybe in 10 years, erg's going to be, $100, $1,000, and I'm just going to sit on this, kind of like the idea of like Bitcoin and miners back then. Yeah. Yeah. Yeah, absolutely. Hmm. Yeah, you're good to go. Right. Pay a little premium. Right, right, right. Yeah, exactly. And then that's the key takeaway, right? And so then if your erg price is greater than your cost to mine, like we were just saying, it's profitable. Otherwise, you're at a loss. And then but a break even is also nice. Um, So yeah, variables change. So the erg price is going to fluctuate. That's why a lot of miners, like Son of a Tech, he's always saying, to pay off your electricity first, because first and foremost, it's a business. And then if there's any extra, then just hold on to that. But everybody's sort of game plan, I would say, is sort of different. You can certainly gamble by mining. You could say, forget it, I'm just going to pay the electricity bill because I can pay that electricity bill and just gather as much erg as I want and just kind of see what happens. Um, so yeah, other variables, right? The network difficulty increases block rewards. And then of course your electricity rate. They may come knock on your door and say, hey, you're using way too much electricity. You're gonna start, paying more prices, which is, I've heard is this thing. So yeah, so we have long-term ROI considerations. So we, beyond daily profit, we have hardware depreciation over time. These things are running 24/7. They're going to be collecting dust, inherent entropy within the system, right? Erg appreciation potential is hopeful. Resale of the value of the mining GPUs, that is certainly has been the case. I have seen that maybe less and less in the future. Like for example, I bought these what are they? AMD cards, and they were about 750 in 2021, and now they're like $100. And so maybe the resale value of mining GPUs, that could be the case, but currently I don't believe is the case. Tax implications, of course, of the United States. So yeah, HODL strategy, really just mine at the low prices. Forget your electricity costs, just pay that. Um, and then you have potential 10x returns. Hopefully, we'll see. And then mining is in a sense dollar cost averaging into erg, and so but I think there's like certain byproducts potentially of like as a result of that. So if you live in like a colder climate, you could recapture a lot of this energy that is the heat. You could then put that back into your house. I know a lot of people do that. I used to do that when I lived in Colorado, kept my garage very nice and toasty when it was, close to 0 degrees or 20 degrees. And that's just kind of moving into the here. Emission reduction impact. So right now, we have 12 ergs is the block reward. So 8,640 ergs a day. Then we move into 9 ergs. So 6,400 ergs a day, 6 ergs, 4,300, and then 3 ergs forever is going to be 21 ergs. And so will most likely be some sort of squeeze in the amount of just scarcity, right? So early miners, we're saying here, have a massive advantage, especially when we were mining, taking away at like really high rates at like 70 ergs or 65 ergs for the block reward. Uh, no, it's the if yeah, and then it's just demirage, right, right. Mhm. And so talking about the algorithm, it's a cool algorithm. So it's very good on your specific hardware, which is great for longevity. Because, again, talking about buying equipment, you potentially want to just buy this equipment and never have to buy equipment again. But most likely you're going to be buying secondary used GPUs that have been running for a very long time anyhow. And so you want to run it on something that's going to be running 24/7, running that's not, really stress testing these GPUs who have already been most likely, abused. Power efficiency, I think, again, is like very critical. I used to mine, and I used to say, oh, I just want the highest hash power. But in reality, especially at like economies of scale, you can start to get, at maybe like 1 or 2 GPUs, no big deal. But you get 5, 10, 15, 30 GPUs, this economy of scale with like the specific rigs and all that electricity cost, just it doesn't really make too much sense. Um, And so running cooler means your GPUs last maybe 2 to 3 years longer, 10 to 20% power. You might have some less, rewards within Ergo, but I think again, it's like we want to be able to like mining is like a game that you want to. It's not like to win. You want to just like play the game, and so like that's like the goal here. Not necessarily winners or losers. Just want to keep staying in business. And so, right, so that talks about like longevity. So thermal stress, fan longevity. So if there's any inherent noise that you don't necessarily notice, that's like inherent entropy within the system. And so maybe something's off tilt. And so maybe every 6 months, it's good to have like a plan. Just take off the rigs apart, clean them all off, put some isopropyl alcohol, get all the dust out of that. Especially for the fans, right? Because if you have more mass that is the dust spinning, they're going to have to work harder. Those motors are going to have to work harder, and that's just going to put more just inherent stress on the system. Not good for longevity. So we have a memory intensive mining. So how Autolycos works is a memory hard computation. GPU core sits relatively idle, but we focus on VRAM. 6 GB minimum, 8 GB plus optimal. Of course, different tuning. So underclock the GPU, overclock the memory, reduce voltage. Again, highly recommend. Efficiency is key here. And so, yeah, you want to find that optimization sweet spot. So you can, again, yeah, like we were talking, right? It's like 80 to 90% of that max hash rate. So you can get, 60 to 70% power. And that even kind of even talks about too, again, like the longevity of things. So, if you've got like a really nice electric rate, and you're using like less power, you can actually put more cards on top of the entire like electrical network that you have, because then in theory, instead of using it, the total capacity, you can maybe fit like 1 or 2 extra cards on there to make up for the lowered um, hash rate because of the clocks. Hmm. Yeah, that's fair. Right. Hmm. Totally. Yeah. Yeah, Canon was just talking about, just the efficiency of the cards compared to like something like Kapow and, you know, you really just want to take care of them, it's just like, but you do have a good point to where it's like, I want to maximize for this, 3 month period, because in the next 3 months, you're going to be getting arguably less. So then you could even think about it as of like right now, hey, I'm just going to mine until it hits the three. So then your electrical rate is essentially fluctuating because now you're actually getting more transport. Like a year from now, you're going to be getting less. And so you could like recalculate what the actual cost would be to a future and I don't know, do some weird accounting, I'm sure. Right. Hmm. Hmm. Yeah. I don't know. I'd maybe push back on that because NVIDIA came out with a card solely for mining. And when they first came out with it, so it's the CMP 170HX. It was 5 grand for that card. Now you were just showing me today it's like 300. So it's like, and that was maybe 2 or 3 years ago, and that's um, it's like 300, even 400 gigahash or mega hash for that one card, you know, versus I don't know the newest cards they're pumping out, but oh, sure. Absolutely. Right. Yeah, it could be. Right. But but what's really nice about mining is we were kind of talking about it a little bit yesterday in one of the side discussions to where, like Virgin coins, a Virgin wallet where it's like, you know, it's literally only Erg coming in here is mined, so there's no sense of like nobody knows where you're at. You're in your own island except the mining pool, but like there's no other transactions like tied to that. And I kind of like that idea to where, you build up a nice stack and then, nobody can like tie that to me. It's often, I mean, you can use a mixer, I'm sure, but like people can then see you use the mixer. So it's like a very anonymous way to like just dollar cost average into Erg. You could even move to, you know, um, they have like hosting farms where they like make deals with you and you just send your stuff to them and they're like, oh, we'll give you this, electrical rate and in return. But I'm seeing less and less GPUs do that, more and more ASICs for sure. So. But there's an opportunity, I think, you know, with solar renewables, great opportunity. I think they're relatively cheap. You could build a nice solar farm, there, and then next thing you know, you have free, you're just printing, or because then say all the equipment's all paid off, and then if you've got all the other equipment for the solar paid off, and then you're also, routing that heat to heat your house. You have this really nice, efficient energy making machine where it's just printing erg, everything else is paid off, and then the heat's going back into it. So definitely. So ASIC resistance, so fair mining, and I think that's a huge aspect, because I came into, certain cryptocurrencies, and then it's like, come to find out, you need to buy so much to sort of be able to say, you know, like in Cardano, if you want to create a stake pool, you really kind of need like so much ADA to find the block or create the mint the blocks, versus Ergo, you can just say, hey, I'm gonna buy this GPU setup, just point to the pool and you're making money like ready to go. Um, and it could be even used as like a burning mechanism. You could be like, okay, hey, this guy needs needs some erg, and just turn on a rig and then anonymously like fund them. or something like that. That's what we're talking about. But um, so fair competition, your GPU competes on an equal footing. True decentralization, so mining power stays distributed globally, ideally. Um, Dynamic protection, so scheduled memory increase, brick any ASIC attempts, and then community focus, so mining rewards stay with individual miners. And I think that's a huge one. I think with the whole ASIC thing, like we really, want to. I think we've seen the rise and the fall of like the various chains that have then said, okay, hey, we'll allow ASICs to come in. Here we have a hard, yeah. Well, I think it's the algorithm, right? So it's like we decided to use this algorithm, and then we'd have to fork it, I guess, to change the consensus layer. That is the algorithm. Hmm. Hmm. Yeah, I'm not too sure. Hmm. Right. Hmm. Yeah. Only time will tell, I suppose. Hopefully. Yeah. Right. Yeah, absolutely. Yeah, we can say all these things, but we'll see what comes out in the wash, I suppose, right? And so here's some of the hardware requirements at a minimum. If I know, I think we were at 4 gigs for the VRAM like maybe a few years ago, and then it went up to 6. And so I had a couple 4 gig cards that obviously wouldn't be able to support this anymore. But I think that's an opportunity for some sort of side chains that's been talked about. So then we have single GPU and multi GPU. So yeah, your single GPU really is going to be like your gaming PC, maybe your workstation, testing the waters, low barrier to entry, um, ROI potentially 12 to 18 months. We say typically, but who knows in this market. Um, so sort of a smaller investment depending on like what sort of setup you have. It could be zero because you could have already potentially have it. Now your multi GPU setup, this can be somebody for it's like, all right, I want to, really want to get into this. You have the electricity cost. That's like one thing. It's like it's one thing to be like, hey, I'm gonna do all this. I'm gonna run 5 gigahash, but then it's like, well, do you have the electricity to do it? Do you have a 30 amp outlet? Can you pay for somebody to like install the 30 amp outlet? Do you need 50 amps? What's the safe like wattage to run on 30 amps? Knowing all that stuff. Even like the cords is like extremely important because if you say, hey, I want this specific card to run at, 300 watts, but the cord is only good for like 250, you're going to start a good fire. And so that's definitely, or even like, you're using a specific like 3D printed hanger. So one time I 3D printed and created my own hangers, and so they'd hang, and you'd have like an open air frame kind of going through it, and sort of like and I was actually just at breakfast with my wife, and I was looking at the camera, and then as I was looking at it, one of the GPUs fell because after a couple months, and I was using PETG, but after a couple months of just being warmed up, warmed up, warmed up, the screws started to sort of create the hole a little bit bigger and bigger, and then eventually just would fall out. So it's always good to, again, have those sort of like backups and cameras and, things, because it would suck to put $3,000 to $10,000 down into this, get it all set up, brick a machine, brick like a motherboard, create a fire for, all of this sorts of stuff. So definitely do the single GPU setup first, get your feet wet. Right, yes. Typically, right, yeah. Probably a lot longer now as of yesterday. These were made, yeah, a few days ago. No. But yeah, I mean, I think that's it's a good point. So Grayman mentioned, college students, they don't have to pay for their electricity. So that's a great like vector, or even Airbnbs. I've heard people get Airbnbs, will see that they have like a 30 amp port over their entire like setup, get like free electricity. It's a way to do it for sure. And so let's break down the different mining rig components. So we have open air, which is nice, but it has a lot of like different moving parts. And so I think again, kind of going back to that idea of like entropy, if you have like a lot of components moving within the system, something is bound to break, and you're sort of like as strong as your weakest link. So if like a PCIe board riser goes out, well then that's down, but then you've got to move everything, and if you've got I've had at most like 13 cards in there, and you have like the chords like managed very nicely. It's kind of a pain in the butt to take one card out, switch that out. I I prefer the server cases. Like on Amazon, you can get them, I think, for like 500 bucks. You can put 8 cards in there. It comes with fans. It runs Windows, but you can put in, of course, Hive OS or anything like that. Um, highly recommended. And those are stackable. Then you can move them anyway. Versus the open airframes, definitely not the case. Hmm. Totally. Right. Totally. Yeah, a lot of aftermarket parts out there right now. Probably for cheap, you could just put something. Right. Yeah. Totally. Yeah, I think definitely. The thing I think you need to worry about potentially with mining with that sort of approach is like there's a lot of move to LLMs being moved to like local. So I think before, the video game group was getting upset with like crypto people because they're buying all the GPUs, but now I think there's going to be a move to where now all of the crypto guys are going to be upset with the AI guys trying to buy all the GPUs, because I think there really will be more of like a privacy sort of thing with LLMs and being like, hey, I want to run it on my stuff. I don't want people knowing like what my prompts are and things like that. And I think the tools are generally moving more towards open source and being able to run them sort of locally. And it's pretty easy to do. We've done it. We've committed a couple websites. So just some sort of food for thought there. And then I think that even kind of goes into the idea of like, hey, I could create like my own LLM setup. And then when my family's not using it, maybe from like 10 p.m. to like, 6 a.m., it's just mining Ergo. And it just has like that script that's running. All right, okay, cool, turning off into offline mode. Now I'm just gonna mine Ergo, turn it back on. Now back to home LLM or whatever the case. Yeah, right. Yeah. Yeah, home LLM or whatever, LLM you want to call it. Yeah, 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 exactly. Because I think as we move further down with LLMs, and I know I'm kind of veering off a little bit, but like, you could have like your cameras set up with like different MCP servers and, your cameras in your house, you maybe want to access that LLM to have that. But then now maybe Google or OpenAI or all these people sort of, have this data that is like your kids or your family. And so I think that's where the privacy is going to maybe potentially come in you know, or just listening to you and you just want to be able to say, hey, home LLM XYZ, you don't want it to. Right, yeah. Totally. And then it's like, cool, we have our own little LM setup. It does whatever that needs to do. But that same infrastructure can then be flipped on its head when we're not using it to then run at night and mine Ergo. And then plus they're both going to generate heat. So I think there's opportunity there to create, heat, especially for like things like, hot yoga. Like makes no sense to just have like a heater when you're just constantly going to be like purposely heating something. So it kind of maybe makes sense to have like a bunch of miners running even if you are, and that's where I think, the heat perspective, you could even flip the electricity cost on its head because then it's like, well, I don't really care. We're going to burn this electricity anyways, but now we get another asset to kind of go inside of it and just like we just get that and then we just actually get a discount now. So I think a lot of the mining stuff is really kind of how you look at it. So maybe one way it looks like a circle, and then like the other way it looks like a square, sort of like, that kind of famous example, right? Just depends on like how you're looking at it. So yeah, understanding the problem. So each GPU generates 100 to 200 watts of heat. Six GPUs could produce 1200 watts of heat, equivalent to a space heater. And of course, we're not even talking about noise. The noise is also a big problem. So I'll just continue here. So single rig heat management. So yeah, right. We're just talking room positioning. So keeping away from walls. I think one of the big things with mining, people don't really think about is this concept called like heat transfer. And so really it's the idea of like you have like something generating heat, but we're not really thinking about like how are we going to actively like move that out of like this like system. And you could like think of this room as like a closed system, I suppose. And if you have heat, how is it going to generate and eventually low or assimilate to like the main temperature. So like if you think of it like water, so if you have like water that is like, room temperature, but then I pour a little bit of water, eventually it'll take some amount of time for this whole water to be the same temperature. And so that's sort of like what heat transfer is. And you want to be able to effectively, especially if you're trying to minimize the effect of the heat, you want to be able to understand. So like some people will create like a rig room and then they'll create like and they'll keep a heat wall and then they'll create their excess. So they're kind of creating some insulation sort of in that sort of slow or helps to translate the heat in some manner. Cool, cool, cool. So yeah, multiple rigs, definitely a lot of heat. The challenge scales up. So 10 GPUs of almost close to 2,000 watts of heat. It is very hot, very loud. The infrastructure needs, I mean, and that's like a serious setup. Even 30 GPUs, it's like sometimes they go down, you got to turn them back on. It's definitely some months they can run like no big deal, and then other months it's like, dude, every week I gotta all right messing with it. And it's like oh hey honey, I'll be right back. I gotta do something to the rigs, and it'll be like a few hours later, and it's like, okay, I'm finally done. Um, so a lot of problem solving, but like for me, I really enjoy that because it could be a bunch of different things. Um, so yeah, so we have smart solutions. So yeah, maybe you got basement mining. So warm air rises. So if you're gonna mine, put it into the lowest point of that you can. So eventually the heat will actually rise. Garage with ventilation. So I was mining in my garage, and so the warmer months I was actually to open up both garages, and so I was able to just draft that heat super fast, which was really really nice. But the problem with that is inherently that's a warm solution or a warm like area, so bugs are going to naturally like attract to that spot. So for the open air sort of cases, I'd have to go in there and get some, air in a can and just like just clean that all up, because otherwise that organic matter will just collect up, create dust, and eventually could catch fire. No good. It's one thing to get, involved with mining and tell your wife, hey, we're gonna put 10K into mining, do all that stuff, to only cause a fire. How stupid would you look, I guess. So in hot climates, AC costs are going to probably kill a lot of profits. But I think that is kind of where you need to put your engineering hat on and sort of see how can you. So the idea here is you got to keep the actual cards cool, not necessarily the exhaust. And so if you can keep that airflow, what's called laminar, but also like over the card at that same temperature, whether it's called like 100 degrees, I guess, whatever, I think Celsius. No, that doesn't sound right. Fahrenheit. Yeah, Celsius. Okay, yeah, that's okay. Then that's fine, or if that's, or keep it, 80 or 90 degrees Celsius, no big deal as long as it doesn't skyrocket up. But it's definitely a hard problem to do. So maybe mine at night. Again, it's all about your specific, like where you are, where you're located. Maybe there's an opportunity to build some sites on land. Maybe you can dig down in the ground. You can actually build up vents and off gas that heat to some sort of like, you know, greenhouse, things like that. There might be an opportunity, especially out here in Colorado. They grow a lot of pot from my understanding. They probably spend a lot of money on heat. So what if they had a bunch of ergo miners underneath somewhere and then off gassing that heat and back into the grow house? And so that would be like a huge net positive. Um, there was actually I went on a tour like on one of the dispensaries, and they actually built the heating mechanism outside of the property, which makes no sense because now it's not even insulated. So now you have hot air leaving the building, going outside to where it's cold, and then going back in. It's like, no, you should have kept that inside. So again, it's all about like, efficiency for the cards, but then also efficiency from a environmental perspective. Um, yeah, right. Yeah, we need to do like a chain cash. Do like a chain cash, and then we'll buy a bunch of property, and then maybe a barter system to be like, okay, who's gonna build the deck? Okay, Mark's gonna build the mining setup, and so on and so forth. We need a like a senior design project or something, right? For all this. So electricity's rates definitely matter the most, right? So 5 cents to 10 cents. I got 11 cents. I was okay with that at the time. And so so I was running like 5 gigs, 5 gig a hash, probably like a year ago. And I was probably about like 300 to 400 bucks a month. Um, I don't remember how much erg it was, but which is irrelevant, I suppose now, just because of the scheduling. So I don't know if that's a typo. So what are the rates? Many utilities charge. Oh, I see. Right. So different rates. And so off-peak times versus peak hours. And so, again, going back to that sort of LLM sort of concept, maybe it makes sense to run it cheaper at night, the weekends, not using it. So it's going to be a lot cheaper, but versus like peak hours. And then additionally, it's like a note about peak hours. Peak hours are also correlated most likely with peak temperature hours. So it's like if I'm in a hot environment anyways, and then I'm also like getting charged a lot for electricity, probably doesn't make a lot of sense to be mining now that during that time anyways. And I think it's okay to turn your rigs off. Sometimes maybe you've had like a bad month. Yeah. Yeah, so for most mining pools on Ergo, it's PPLNS, so it's pay per last N shares. And so N is set by like the mining pool, and ours right now is like one half. And so you could just think of this as like a window. And so like so say the last 12 hours are all the shares you're gonna like get calculated for. So if you just started you're not going to have a lot of shares within the last 12 hours, and so you get penalized for that. But if you get onboarded to the pool after those 12 hours, you now have the maximum full amount of shares that you could possibly have. But then if you like onboard another gigahash, your shares amount potential will then increase because now you have more potential shares to be able to submit within that 12-hour window. So if you turn it off, and it really depends, like on Sigmanauts mining pool, it just depends on like when we find blocks. So like say for example, you're like maxed out on your 12-hour window. We find a block and that was like high difficulty. Then we have find our effort. Then we find another block within like, an hour. Then we find another block within, you're gonna have a high participation because it's been you have the maximum amount of like shares. Let's say during between the second and third block, you like, all right, I'm turning off for the night. You're still gonna have, say, 90% of that window covered, um, because you have 1 hour less, call it, or whatever like the math like works out to. But then it goes from 1 hour to 6 hours, well now you have 6 hours left of those last shares. And it really just depends on what the N is. And so again, ours is 1/2, but you could put like 4, which could be like weeks. You could do like months. So then, but those are like obviously really old shares, and it's like, we don't really care about that. We just care about like these more recent shares. So that's a way to do that. So then we have solo mining versus pool mining. So you mine alone. If you get a block, you get all the rewards. Very unpredictable, but really it's only unpredictable in the sense of if you have like a small amount of, I mean, I'd say it is predictable, but it's just you're not going to get paid a lot because or soon because if you have like 100 gigahash, it's going to take like 30 days. But you could have like a lot of luck, find it like within the first hour. That happened to me. I was like 500 gigahash and I found like 2 blocks, and I was doing like a test pool, and it was just like just me on there. It was just like, oh well, that works out. No, no, no. And then this pool mining, depending on the fee, you sort of split your hash rate, and then whenever anybody on the block finds a block, or anybody on the pool finds a block, then we all split that with respect to our participation, which is calculated by the PPLNS calculation. And then we also have the small fee. So then we take that erg reward, we calculate that fee, the pool keeps the fee, and then from there the PPLNS gets like added to the shares of like the database. I thought I fixed this, but at one point the Sigmanauts mining pool was 1%. It's variable, so if you want to vote it to 2 and it passes, we'll vote it to 2. If you want to vote it to 0, we can vote it to 0. Any miner on our pool, if they want a DAO token, we'll give it to you. So we're distributing storage rent. We have bonus tokens, doing a bunch of other different things. But then we also, of course, have hero miners, which I believe they're also distributing, or I know they're collecting Demirage. I don't know how exactly they're distributing it. Oh, okay. Uh-huh. Right. Okay. Well, the way we do Demirage distribution is we do it like 1-for-1 um, participation. So for that block, we'll like calculate your participation. We'll then take that same, we like back calculate it, but we grab that value and then we multiply that by whatever like the erg amount we got from Demirage. So if it's like 10 erg and your participation was 10, then you'll get 1. And then that's paid. Traditionally, that'll be paid every Tuesday. Um, but there's some sniping wars sort of happening. Sorry, say that again. Yeah, for sure. There was like an opportunity a few months ago where there was Cannon can correct me, but I think there was like 1,000 SIG USD in Demirage. Wasn't it something like that? Or there was like 1,000 in token value. Yeah, yeah, yeah. So definitely the incentive is there. Okay, that's what it was. Yeah, SIG RSV. Okay. Yeah. Yeah. So let's see. And it says two miners is two. I think they do what does anybody know what their payout is? It's not PPLNS, right? It's like what it's like a Bitcoin. Isn't it a bit like Bitcoin pools do it? No? Okay. Fair enough. Um okay. So yeah, talking about the Sigmanauts. So we have a DAO run on Paideia. Everybody has a say in the pool. We actually have 10,000 ergs in our treasury, which is awesome. Only pool right now distributing. Well, that's not true. Sorry, I thought I fixed the storage rent, but the only pool distributing bonus tokens to our miners. I think at one point we had like 60 tokens that we'd airdrop all at once to. I think at most we had like 60 people, so that's kind of cool. Um, we're supporting the ecosystem, so fees fund Ergo development and community projects. All decisions voted on the community are all open, active, Discord and Telegram. We have a bunch of different alerts, so every time we find a block, really good group of guys. If you're interested in mining, people are there from like, all over the world. So if you have a question, generally somebody's on there, answer like whether it be about mining and something I really like about our mining community is I like to think that all the miners are devs in hiding. They just don't know it yet. They have like a technical ability of be able to spin up a miner, put up the OS, that takes some, noodling within the terminal and things like that. And so we were actually able to get two of our miners to join the last hackathon. So that was pretty neat. And so storage rent is Ergo's unique feature. So rent, and so this is also Demirage. It's collected from unspent boxes older than 4 years, prevents the blockchain bloat, and provides additional revenue for the miners. And so here's just some sample current revenue. This is free money for the most part. It's just there. It blows my mind that people don't consolidate their boxes that are more than 4 years old, but maybe they left the community. And so yeah, on Sigmanauts mining pool, I wrote a script that will distribute it all proportionally to the Sigmanauts miners based upon our participation in the database. It increases your effective earnings. I guess we're the only. Well, I guess Grayman said they're distributing it, but equally. I'm be curious to see how exactly. So that's right. It would be it would be good on us to put from a transparency perspective, be like, hey, this is exactly how we're doing this. Just all the FAQs and stuff. I'll have to take a note of that. But yeah, our fee is 1%, so sorry for all the spam of the 0.9. Our minimum threshold is 0.5. We did create this protocol. I don't know if it's really a protocol, but essentially you could mint an NFT. You could then inscribe in this NFT your minimum or your payout threshold, and then our system would then pick that up based off like our collection ID, and then from there it would automatically change your payout threshold without having to like message me or anything like that. So a little bit more permissionless sort of payout thresholds. Because we have some miners, right? They might have like 50 gig of hash and they might be making, 10, 20, 30 gigs or ergs a day. And if it's 0.5, they're just getting a lot of spam. And so from like maybe even a tax perspective, it's nicer to have it in one transaction as opposed to like 5 transactions a day. Plus, from the mining pool perspective, I'd say we don't want to make 5 transactions a day if we can just make the one to save on the TX cost, I suppose. So yeah, if you need to get help, we're pretty active on Telegram and Discord. Let's see. Mining with Sigmanauts isn't just about profit. It's about supporting the true decentralization and being part of the community that believes in Ergo's vision. Mining fees fund ecosystem development, not just corporate profits. And then, of course, we can vote on those specific developments. It's not, something like, hey, I want to do this and we're going to spend this. It needs to be, voted on everybody. So if you want to get started with mining Ergo, you need a mining wallet. So Nautilus is what I would recommend. Get a mining software. Really kind of depends on it's NVIDIA or AMD. Mine to the Sigmanauts mining pool. Check out, I think it's ergominers.com. is our dashboard. You configure the miner within your wallet, start mining and monitoring the pool dashboard. Again, join our socials. So here's a couple different mining options. Just kind of for the sake of time, kind of get through these. So yeah, optimize again for efficiency here. So yeah, why Ergo? So we got the cooler algorithm, uh, better for GPUs, declining emissions, so for scarcity. So I think that's been like a big thing for a while. And so now we're actually like in the next year, we're going to see that play out. And, is that sort of narrative true? I don't know. We'll find out. ASIC resistance, storage rent income, an active ecosystem, no pre-mine or ICO. We're going to be mining until 2045 and expert developers. So resource and links. Start your mining journey today. Comments, questions, concerns? Yeah. What is my, yeah, I think it's pretty cool. I think, Sigmanauts, I think we probably have, the way I'm thinking about it, we'd have like two separate options. And I'm still sort of fuzzy on like the entirety, you know, aspects, but I think we could probably have like a Sigmanauts mining pool is how we run it today. But then also, huh? Yeah, I think we could do that, irrespective, but we could probably have to do a DAO vote if we wanted to do, one or the other or do both, you know. I'm completely open with what, the DAO wants to do. So, kind of open to, so absolutely. Yeah, true. Right, right, right. Yeah. Hmm. Yeah. Yeah, yeah. I mean, that would be a really. I'm not sure if Mining Core does that. I mean, Cheese, do you know? Like, it is does. Okay, sick. Right. Mm-hmm. Totally. Yeah. Yes. Yeah. Yeah. Some guy named Oliver. But yeah, that'd be a really cool idea because I mean, and then can you overstuff the transaction? So if I'm like in the pool, right, and you're saying, hey, I want to make the transaction, could I like put as much as I want in there? And then that would essentially push out, right? Mm-hmm. Right, right, right. Yeah, that'd be a cool idea because right now for our bonus tokens, we're doing that once a week and okay. Yeah, no, that's definitely a good. I'll be relying on cheese there to, to help us out. Sweet. All right, cool. Any questions online? I don't think so. All right, cool.
Hi guys, I'm Allison. I'm here for some years and involved in some major things on Ergo, like Nautilus Wallet and Fleet SDK and so on. And before I start, I would like to say hi, glad I am to be between you guys. So it's really nice to finally meet every one of you personally. So thank you for making it happen. So let's talk about Machina, right? So that's right. So M- Machina is P2P decentralized exchange on top of Ergo blockchain. Um, we like to think it about like something like UTXO native application because um, so far most of applications on UTXO model tries to somehow emulate how EVM contracts works. So we are trying to do something different there. So where each order on the exchange is individual contract, so I think it's the best approach for UTXO uh, structure. So it's peer-to-peer because you open orders directly and somebody buys from you with no intermediaries or no batching, third-party batching mechanism. So it's based on grid orders of instead of liquidity pools. So it's pretty novel. We are taking advantage of Kush's idea on his grid contracts here. So this contract is basically you set orders. So when somebody buys or sells from you, it creates an inverse orders, making a profit difference between transactions. So it's also self-custodial. So you can you have control and ownership of your assets from end to end. No intermediaries here. So and as I told, no intermediaries and also no proxy contracts. I'm not saying that proxy contracts are bad. They are good in some points because, for example, it's a good strategy to create some kind of incentive for running infrastructure, but it's not so transparent from a user experience perspective. So because you are sending assets to a string basically, and you need to hope that assets get back to you. So it's kind of not really transparent. So yeah, we are trying to do this on the more transparent way. So for this to work in a more and having concurrence in mind, we need to do some changes on Nautilus side because we need batching anyway. So what I'm trying to do is to implement a batching mechanism directly on Nautilus. So you agree if a certain slippage tolerance, so it will resign this transaction as many times as possible. So you are your own batcher. So and as and the last point, as everything on Ergo, it's open source and verifiable, and yes, as everything should be, right? So we have Services is structural overview here. So as you can see, it's a pretty simple one. But this has a reason to be like this. Because we believe in true decentralization, and decentralization games not only on using a blockchain as a settlement layer. You need to run your own transactions, your own batching. So the entire application logic it runs exclusively on the user browser. So UI will do most of the job. So interpreting UTXOs, parsing, batching, composing transactions, and so on. And on the other side, we need some kind of real-time UTXO transaction, UTXO streaming. So here's an Hermes comes to play, which is a tool we are building. It's a simple one. It just takes data from an indexed node and streams it directly for the UI. So it's not something um, really complex. It's generic enough for any other application to make use of it. So it's not our actual backend because anybody can run it, even locally, and have fun, be your own bank. Yeah. So contracts, we have currently two different trading strategies i- done. It's which is auto compounding. So when you create multiple grid orders, everything let's say you create an order selling Ergo for SIG USD. So everything you sold, you'll be used to buy lower. So you are maximizing profits and potentially losses. So, and alternatively, we have a cumulative strategy, which is we use fixed rates for buy and sell. So we buy at fixed rates and sell and fixed rates. So the profits are accumulated and separately. So it can be a more conservative strategy. So it's composable. All contracts are composable. So which means you can, for example, borrow something on Sigma Phi or do pools and right away um, do some tradings on Machina in a single transaction. And other protocols can use its liquidity to to make wherever they want because it's easily composable. So and yet on composition we have some characteristics we wanted to have from the ground up. It is highly optimized. We spend a lot of time optimizing code on building Ergo tree to have to can fit as much as orders in a single transaction as possible. So our biggest grid contract has around 300 bytes, and which allows us to fit around 219 orders in a single transaction. So it's pretty usable right now. This is the biggest one. We have, for example, single buy on sell orders that are like 16 bytes. It's ridiculous, yeah. So and also no built-in protocol fields. So it's okay. Yeah, don't think so. Yeah, 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 exactly. Yeah. Yes, we are assuming here we are using regular 97 kilobytes transactions, which is the regular transaction that the nodes accepts by directly by main pool. But mining pools can do transactions as big as they want, so can be even bigger. So yeah, yeah, yeah. This is a concept we are maturing for years. So we reached to the decision that protocol level fees are not good for ergo growth as a world. So we just gave up on this and let's make some a public good, right? So yeah, absolutely, yes. It's like Sigma. I'm sorry, some Sigma USD, right? Yeah. Okay, thank you. So, yeah, oh, thank you. So, as with no protocol level, any other application on top of Ergo can use Machina's liquidity and do wherever they want. So, yeah. So now we talk about a little bit about Ergmis, which is a tool that we use to make real-time price tracking and UTXO streaming possible. So it just takes UTXO from the indexed Ergo node and streams to wherever they want. So it's also main pool aware. So you can chain transactions by default because currently it's pretty complex to keep track of maple state. So I wanted to take care of it. So yeah, yeah. I don't have I have no idea. Yeah. Next is one transaction. Is a Yeah, 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 yeah. Exactly. Yeah, yeah, yeah. Sure. Yeah, yeah. It's crazy, right?
Hello. Yeah. So I was saying that so we can do an 290 transactions per block per trans sorry 290 orders per transaction at the worst case, right? So all these orders are like using the biggest contracts. And then, as Allison mentioned, that we can do chained transactions, right? So you can submit transactions one after another without having to wait for confirmation. So if we know the what block size limit, I'll check after this, but we can theoretically do like 290 orders times the amount of transactions per block. So if it's like
Yeah.
what 100 transactions per block, we can have what nearly 30,000 orders, right? Per block. This is huge compared to like what exists right now on like Ethereum or Cardano, right? So I think this is pretty impressive, something to think about of leveraging UTXO's capabilities. Yeah, I don't know too much about subblocks, but with subblocks too, we can have so much just really high throughput potential here. So
Yeah, I think sub blocks will have similar capacity that you'll be just fitted on a main block. Oh, yeah, yeah. I think liquidity must be constructed. Yeah, but I think we have a natural incentive here because market can explore arbitrage between, for example, Ergodex and Machina. So I'm not too worried about liquidity right now because we are just building things. But yeah, I think it's eventually. Sorry, Camille. Yeah, exactly this. Yeah, 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 yeah. Exactly, exactly because you set up grids. You are your own market maker. Yeah, yeah, absolutely. And also controlled risks because you are controlling your exposure, so on a certain range. So yeah, yeah. Thank you. So it's back to Hermes. It's main pool aware. So which means um, back in Nautilus team we have a philosophy that every product we build we try to extract some outcomes of it. So, for example, we built Nautilus, um, fleetest decay is outcome of it. It's a positive side effect because we needed a powerful transaction builder tool. So I needed to do this from ground up. So I did it as a library so anyone can use it. So this is the same for Ergmis, because it's depth agnostic. Anybody can make use of it and have real-time UTXO streaming and maple-aware um, transactions. So, uh, and as a last point, um, I have to confess something for you, you guys. Uh, GraphQL was a big mistake. So, we built that in a try to make Ergo work properly back in URI. So, but it's not successful. So I took advantage of that, and as we have at least a caching layer and integrated inside Nautilus, but yeah, I have to confess it's not perfect. So Hermes will replace GraphQL on Nautilus, so hopefully we have a way better user experience there. So roadmap, 2 weeks, right? So we already have contracts done and under closed review by some community guys, and by the end of this year, I want to have Ergmes fully functional and Fleet SDK for Q1 of the next year. Sorry, not Fleet SDK, but Machina SDK. Because it's important to have an SDK because we empower community to build stuff even before we have a functional UI. So they can use it and integrate it in any way they want it. Yeah, exactly. Yeah. So they can, for example, build arbitrage bots and something like that. And we they gain some time so before release. And on Keytrue, our plan is to have our fees end-to-end beta on mainnet. So let's hoot for it. So thank you, and yeah. Okay.
Yeah, so I did the
Here?
calculations. Yeah, perfect. So I did the calculations, right? So the maximum block size is 1.27 million bytes. So like
Whoa.
1270 kilobytes is the maximum block size. So and the maximum transaction size is 96 kilobytes. So that means you can have about 13 max size transactions per block. So if you're doing what 290 orders, right? And that's the max that fills the 96 kilobytes, right?
Yeah.
Yeah, so we can do about 3750 orders per block. So that's not as much as I probably claimed, but that's still a lot compared to definitely more than anything Cardano does for sure.
Yeah.
So, and again, guys, as Joe mentioned, this is all open parameters. So miners can vote for a larger block size, right? So when the demand comes, we can all like vote for like a bigger blocks, right? And we can squeeze in so much more orders per block. And yeah, just the throughput will be really fast. So this is
Yep.
really impressive. About 3,750 orders per block.
Holy shit. Sorry.
Yes, that's in the worst case. That's the worst case.
Yeah. Worst case. Yeah.
Yeah. Do we know best case? How many orders? Like the
No,
smallest orders?
not many, but I can check right now.
Okay. Use your what Ergo script CLI tool.
Oh, it's not broadcasting anymore.
And I think you
Yeah. So
stopped.
let
Yeah, you stopped.
uh I haven't done it yet, but it's yeah. Yeah, but I think the baseline we usually do like 0.011 ergo. Yeah, so it's pretty much enough for most of transactions. Yeah, because for simple P2P transactions, this baseline is already way overpaid. Overpaid. It's uh, yeah. Oh, it will be not backwards compatible because it needs to use WebSockets because it's real time. I'm sorry? Streaming, exactly. Yeah. 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 Yes, because currently a lot of times do real spamming on Explorer infrastructure. Yeah. Yeah. So if real time is streaming, we can lower our maintaining costs while getting real time. So anybody else? So that's it. Thank you. Yeah. 3,000, 3,750 transactions per block. Yeah. Worst case, yes. Yeah, yeah. Yeah. Okay. Uh, yeah, best case is like 16,000 transactions per block. So pretty much every. Okay, so I think we are done.
Hey, everybody, thanks so much for joining us today. It was a long day, but speakers were absolutely amazing. It was great to hear from everybody. Sorry we don't have time for the AMA, but we will continue that next Thursday at our normal time ANA. Come by with some questions that you have for this, and everybody will be happy to answer.